upside down. Tell me where I'm going wrong. We don't have to be alone. I can see them brighter days. I can see the sun breaking through those clouds. Heaven knows we're all afraid, but we just keep holding on. I can see them brighter days. I can see the sun breaking through those clouds. Heaven knows we're all afraid, but we just keep holding on for the brighter days. Oh, we just keep holding on for the brighter days. Oh, we just keep holding on for the brighter days. It's a fine line between the light of day and the dead of night. I'm on the outside, looking for a reason to change my mind. Tell me where I'm going wrong.
Ladies and gentlemen, good afternoon. Welcome to the 2019 COMPUTEX Forum on AIoT. AIoT is driving innovation and development in areas such as semiconductors, smart transportation, smart healthcare, and smart cities. Today's keynote speakers from Intel, Micro, NXP, Advantech, CyberLink, and Supermicro will speak on this topic and explore how the synergy can create efficient solutions and develop industrial growth momentum. Ladies and gentlemen, to kickstart this afternoon's program, let us invite Mr. Walter Ye, President and CEO of Taiwan External Trade Development Council, TAITRA, to deliver his welcoming remarks. Please help me welcome Mr. Walter Ye.
Hi. Good afternoon, our honorable speakers, distinguished guests, ladies and gentlemen. Good afternoon.
Good afternoon.
大家午安. On behalf of TAITRA, the organizer of COMPUTEX and COMPUTEX Forum, I would like to welcome all of you for joining this session, AI and IoT. And I would especially like to extend my great appreciation to all the industry leaders, our honorable speakers, for your contribution. COMPUTEX started from yesterday. Actually, started from the day before yesterday, from the keynote, kickoff from the keynote. And until today, we have so many new product and technology launches here in Taipei. So like Intel, yesterday launched their new products, and also other leading tech companies announced new technology and solutions here in Taipei. So thank you very much for use this COMPUTEX platform to introduce your technology to the industry. COMPUTEX, we celebrate 39 years. And now it is it's not just a sourcing platform, not just for procurement. It's also for building global technology ecosystems. So I'm very happy to see so many companies invite their ecosystems, supply chain together here, work together for the industry. And today, AI and IoT is very important. And for the exhibition, Nangang Exhibition Hall 2, we have IoT Smart Tech at the Nangang Exhibition Hall 2, which is very popular this year, also involved with this afternoon's subject, AI IoT. So I would invite all of you after the seminar, please find time to visit Nangang Exhibition Hall 2, where the smart tech, the IoT application will be there. A lot of companies from all over the world will be there to show their latest technology for application and solutions. And also, I would like to invite you to visit the Innovex. The Innovex just opened this morning in the next exhibition hall. We have 25 countries with 467 startups join our Innovex. Innovex just started 4 years ago in 2016, and now it became Asia's biggest startup platform. So we have so many startups from all over the world. We have 12 country programs from Asian countries, from Korea, from Japan, and from China, also from European countries like the Netherlands and France, Germany, Hungary, Poland. They all join our Innovex with a country pavilion. So it is a good place for exchange and also looking for investor and looking for new innovations. And today, AIoT, we are so happy to have the leading speakers here, and they will share with us the latest developments and about AI and IoT. And I would like to, today's speakers, including outstanding speakers from Intel, Trend Micro, NXP, Advantech, CyberLink, and Supermicro. And all these leaders all specialize in the field of AI and IoT. We'll share the latest insights and application. So I would like to pass the microphone to the first speaker. The first speaker is Mr. Joe Jensen from Intel, the IoT division. He's a VP from the IoT group. So thank you so much for joining us this afternoon. And I hope the COMPUTEX Forum is become a very important part of our technology exchange and share the insight from our leading speakers from all over the world. So welcome you again, and thank you very much to our honorable speakers. I hope you enjoy this afternoon's speech and have an informative and afternoon for this forum. And please don't forget to visit our show in Nangang Exhibition Hall and Innovex just next to this TICC, the Taipei Exhibition Center. Thank you very much again, and hope you enjoy the forum. Thank you.
Thank you, Mr. Walter Ye. Please remain on stage for group photo shooting. And ladies and gentlemen, now please help me welcome all the speakers for the afternoon session. To all go on stage for group photo shooting, please welcome Joe Jensen, VP of Internet of Things Group and GM of Retail Banking, Hospitality and Education, Intel. Mike Gibson, Vice President of Threat and Vulnerability Research, Trend Micro. Ellen Yang, Chief Technology Officer, Advantech. Michael Clegg, VP and GM for Embedded and IoT, Supermicro. So now, ladies and gentlemen, let's have a warm round of applause for our distinguished speakers. 我们是不是以热烈的掌声来感谢我们今天与会的所有的重量级的国际级的讲者 Once again, we would like to welcome especially our speakers representing Intel, Trend Micro, Advantech, and Supermicro. Now, gentlemen, please put your thumb up, put your right thumb up for the photographers to take a few more photos. Thank you very much for joining us for the group photo shooting. Thank you, gentlemen. You may now return to your seats. And the first speaker in the AIoT session will be Joe Jensen. Mr. Jensen is Vice President of IoT and General Manager of Retail, Banking, Hospitality, Education at Intel. He joined the company in 1984 as a product engineer and now leads the team responsible for helping third-party brands and retailers use Intel's technology to better serve consumers. The topic of his talk today will be Innovate and Scale with AI and Computer Vision. Now, without further ado, I will now turn the program over to Mr. Joe Jensen.
Living on the edge. For some, it's a phrase living on the edge. For some, it's a phrase that conjures up an uncomfortable sense of risk and uncertainty. For others, it represents the only sure path to experience life's full potential. But when it comes to the impact of artificial intelligence on the future of IoT, there's really only one way to look at it. The edge is where the action is. It's the edge where unprecedented amounts of data will not only be generated and collected, but where the critical decisions directing autonomous vehicles and devices must be determined in a matter of milliseconds. Where businesses and enterprises worldwide will seek to carve out their own unique competitive advantages with the power of data. And while the immense value of the data center will continue to grow for decades to come, many of AI's most promising contributions to the IoT revolution will require the development and distribution of specialized compute resources. Resources designed to enable an exciting new era of opportunity and growth for businesses everywhere, and built right into the farthest reaches of the network and its ever-expanding edge. Which is exactly why you can find Intel there today.
So, ladies and gentlemen, please welcome Joe Jensen.
Good afternoon, and thanks for joining our session today. I'm going to break from a little bit of Intel tradition and not talk about products and chips and semiconductors. I'm going to talk more about the market transitions and trends and changes we see and the massive opportunity that AI technology is going to represent for all of us. So first of all, I'd like to thank Taiwan and thank our partners in this ecosystem. Over 20 years now, I've been coming to COMPUTEX, and I've built some tremendous partnerships and relationships with many of the leaders in this room. Our business has grown tremendously, and I think it's grown together. We face now, and we'll talk about today, really doubling or more the opportunity we've all thought of as the future. If we take a little bit of a look, as we've looked at what AI is going to do and what AI technologies will do for transforming businesses, bringing new business value, and bringing new opportunity for all of us to serve, the silicon TAM, just silicon, between the edge, the network, and the data center for these IoT compute technologies represents $33 billion of market opportunity. So massive, new, and large, and growing TAM. It's not just thinking of how we do processing and thinking in the old style of putting all that compute in the cloud. If you go step back 2 or 3 years ago, the analysts were thinking about, oh, this IoT is all about some little things, Fitbits, thermostats, billions of things generating data, spewing all this data up to the cloud, and then analytics being done in the cloud. We now realize, and the industry realizes, that IoT, especially IoT for business and for business insight and value, is really about unleashing computer vision and advanced AI technologies against large, massive sets of real-time data being generated at the edge. These data sets are so large, we're not going to have the ability to send all that data to the cloud for analytics and processing. A huge amount of those insights will be generated live, real-time at the edge, and that creates the opportunity for us in IoT at the edge. So if you look at this, it's devices, could be little sensors and small things, video cameras, and other data sources, pooling that data together and providing insights and processing that data at the edge. Then sending insights or those kind of new learnings from the edge both back into the manufacturing process or back into the live process that you're running in the store, in healthcare, wherever you're at, and then also sending those insights up to the cloud. Take a look at a couple of verticals here, some of the key focus areas. If we look at retail, for example, if you are in retail, huge trends towards moving vision systems and cameras into retail to better understand shoppers' behaviors, shopper patterns, the emotion and the feelings of shoppers, and then how to dynamically change your offer to those shoppers as they're in the environment to maximize the customer satisfaction and, of course, maximize the sales to that customer. Smart cities, massive opportunity with cameras, not just for surveillance and security, but also cameras to optimize traffic flow, to improve safety for pedestrians, to improve city services. We're adding air quality monitoring, gunshot protection, and all kinds of other new technologies to make these cities a much smarter and safer place, lowering their environmental footprint. Into industrial, massive, massive opportunity in manufacturing. Very advanced factories like Intel's wafer fabrication facilities use a lot of data today, and we've been using a lot of data for many years because of the cost structure that we have and the amount of technology that we've invested in. We can afford to invest a lot in that analytics technology. But as these AI technologies and the ability to process and find insights has become more cost effective, we're now able to bring those insights and bring that capability down to much lower capital intensive, lower cost factories. We've been working with projects across China, North America, and Europe with manufacturers on how to bring computer vision into those environments to help study product quality, measure defects, and to improve process flow. If you see the stat on the slide here, tremendous amount of traffic being generated just with video alone. The next up, I've got a video showing some of the work we've done with Alibaba in China and manufacturing specifically.
When factories rely on human eyes to perform precise inspections, the results can sometimes be less than optimal. In some factories, less than 20% of defects are actually detected, and that means expensive customer returns and wasted machine and worker hours. So we asked ourselves a question: what if Intel's data analytics and high-performance computing technology could enable machines to evaluate product quality on the factory floor while the work is in progress? We turned our eyes towards creating a scalable solution with commercially available hardware and Intel software, and we tested it in the fast-moving China market. It all starts with the camera. A high-definition, off-the-shelf camera is used to inspect the part from all angles. The data streams to an industrial PC, and it's powered by an Intel Core i3, i5, or i7 processor, and these are all compatible with the full suite of Intel-based accelerators. With algorithms created using Intel's OpenVINO, computer vision and deep learning combine, and we use that to evaluate whether the part passes inspection. Other industrial machines in the factory can be connected to Intel-powered gateways that gather and translate data to standardized formats. Then they transfer that over the network to either the edge server or the cloud for processing. The edge server, powered by Intel Xeon scalable processors, sorts and processes the data using Intel's Industrial Edge Insight software, identifying which images and data streams need to be stored. The edge server acts as a scalable on-premise data center in the factory, processing data from multiple machines, consolidating workloads at the edge, and sharing data with the cloud. Factory workers can use ruggedized tablets to check the status of operations. Data is collected over time and is used to identify and address the root causes of defects. The results: from 20% inspection success rate to a better than 99% success rate, which means time and money saved on the factory floor. A proven industrial edge computing platform designed to be scalable, ready for integration into any factory, and already implemented in more than 90 different factories in China.
So take a look at that stat. We've implemented in 90 factories in China. Just to put that in perspective, there are over 2 million factories in China alone with no data, no analytics, and really no computational infrastructure whatsoever. And so think about the opportunity to go bring analytics and data to improve the efficiency and operation of those 2 million factories. And again, that's just China. Globally, much, much larger. At Intel, we've shifted heavily and indexed very heavily our investment to really help our market and help our customers and partners capitalize on this new opportunity. Critical that we have the right silicon roadmap. The foundation is having the right products. We're investing heavily in not only the right traditional CPUs for this market, but also in co-processors to accelerate these vision workloads. And I'll talk a bit more about how we're enabling those vision workloads on a variety of compute architectures. We also see a big opportunity and a big need to simplify how these workloads get put together and how they get handled and managed. If you go into a retail store, we've seen a huge amount of compute for a long time in retail. Every point of sale system is a relatively high performance compute platform, some digital signage moving into those environments. But if you look at the overall amount of compute, or the number of transistors needed, it's been relatively stable for the past 10 years. We haven't seen any really big increases in how much compute those environments require. We now take a look at what AI technologies and computer vision are going to bring. We're going to see tons of cameras landing in this space. We have retailers in China with as many as 400 high-def cameras per store. And so you can see a massive amount of data being utilized. We're going to see an exponential increase in the amount of compute and the amount of transistors landing in retail stores, in hotels, in restaurants, in factories, in hospitals. And that's all a huge opportunity for all of us to capitalize on. But how do you bring a huge new increase in compute and deliver that in a way that's very manageable for customers? We need to bring platform architecture to the edge that's going to allow these workloads to scale and to add new capabilities and new use cases over time. So investing heavily with open source community and creating the right software and solution and architecture for these workloads to land easily into these environments where we haven't seen this level of compute in the past. And then lastly, bringing scale for vision and really focusing on verticals and focusing on the use cases we need to enable so that these businesses can see real value in deploying these analytics technologies. Nobody's going to go deploy a data system, collect data, and process the data if they can't get some insight that's going to deliver business value. And so we're investing at Intel also in understanding these vertical requirements and vertical needs so that we can help those individual or those specific industries get value from their data. We can't do this alone. Intel, we build ingredients. We do a lot of market research. As I said, we're investing in understanding the vertical requirements better and the use cases. But it takes an entire ecosystem for us to bring this value to market. We're also really trying to help our customers and our end users scale faster. And so rather than having to engineer one-off solutions every time, we're bringing together market-ready solutions and RFP-ready kits with our ecosystem so end users can see a proven solution blueprint that's already scaled somewhere, and they can copy and reuse that very quickly, and it helps their time to market and time to money, and it helps our ecosystem scale faster. Tools are a key piece of that. I'll talk a bit more about what we're doing with AI development tools. And again, the collection of people in the room, the names on the slide, really important for us that we go after this new opportunity collectively as a team. Computer vision, we think about AI. It's really AI is a big, broad term. I think the hot area right now that we're excited about is computer vision. And if you think about it for a minute, the most important data type for humans to use when you're trying to go solve a problem in a factory, you're trying to help a patient in a hospital, you're trying to serve a customer in a restaurant, is your vision. We're at a point now where cameras are inexpensive, the algorithms have matured rapidly, the cost of delivering the compute necessary to get real-time insights has become attractive, and we're going to see this AI technologies land everywhere. If we take a look at the size of this opportunity, I've been talking about how big it is. Just in 2019, there's over $1 billion of opportunity in computer vision at the edge in our IoT markets. Massive new opportunity. Dynamic digital signage. When a customer walks by an advertising location, why wait for, why run a random ad or some kind of generic thing? You can actually understand with a camera who's in front of that screen and adapt the sign to them. In healthcare, computer-aided diagnosis, explosive new opportunity. Huge amounts of new compute delivered by our ecosystem here in Taiwan into healthcare OEMs to solve these kind of problems. But the challenge, I think, if we look at our ecosystem, is most of us have not started or gotten to where we are today by being experts in computer vision and AI. And if we look at how this opportunity is unfolded, there's been a huge amount of compute required to do the learning or training of these algorithms, and then you've got to go run the edge inference, take those algorithms and run them at the edge on your live real-time data. And up until now, most people have been assuming you have to have a GPU to do both training and a GPU for inference. The challenge for that, of course, is that a GPU is a big step function up in price, power consumption, and complexity for the customer. And so what we're trying to focus on at Intel is how do we deliver the right level of compute for the workload that you have. You've got one camera, you should have enough compute to deliver AI insights with one camera. You have 3 or 4 cameras, you should have enough compute and the right amount of compute for 3 or 4 cameras worth of insight. You've got a smart city application or you've got a retail store with 400 cameras. How do you deliver the kind of compute needed to run insights against 400 cameras? And so at Intel, we've created a tool solution we call OpenVINO. And with OpenVINO, the best way to think of it really simply is it's a compiler for the algorithm you've trained. So you build and train an algorithm on the framework of your choice, and then you run it through our tool suite, which is really a compiler that optimizes that algorithm onto Intel hardware. And it can optimize it onto a low-end Intel CPU alone, a CPU with a Movidius accelerator, a VPU accelerator, Intel Core CPU, a Core CPU utilizing the GPU that's on die, Intel Xeons with Movidius Movidius accelerators, FPGA. If you need really aggressive acceleration, you can put an FPGA in the system, and the OpenVINO solution will land your algo on the FPGA for you. Really a fantastic tool delivering tremendous results and capability. If we take a look at that, we started, and if you take a baseline here, in December of 2017, we took kind of a base algorithm in the Intel math kernel library, and we landed that vision workload on a Skylake platform, and we call that kind of our base performance. With OpenVINO, we had their first release in June of 2018. And with OpenVINO, not changing anything at all in the platform, just compiling that algorithm through the OpenVINO tool, we're able to double performance. That's really impressive. Same hardware, double the performance. We didn't stop there. In December of 18, 6 months later, a couple of releases later, you can see here now at release 5, we now, on the same platform, 16x performance. And keep in mind, no changes in silicon, no incremental cost, no incremental power consumption. You can now get 16 times the performance that you used to think you could get with an Intel platform. We don't stop there. We add VPUs and accelerators and new capabilities, as I talked about, landing those algos on FPGAs really simply and easily. And then we take a look at Intel Silicon, and we've got, now with Cascade Lake, we're able to deliver 35x the performance that we could in December of 17. Similar price point, similar power consumption. You can see the hardware platform did change, but again, same kind of swim lane in terms of price performance. And we're not going to stop there. We're going to continue to add incremental networks and frameworks and support to this tool suite. We think it's really critical that we enable customers, whether they want to put a single camera on a single compute platform on a camera to look at a dial on a manufacturing machine, and this is a real use case we found in China. Big industrial piece of equipment, 30 years old, analog, little dial to tell you how the machine's doing. They'd like to digitize it. So they put a camera facing the dial and a computer algorithm to read the dial, and they turn that analog input into digital. Simple little use case, land on an inexpensive, low-performance CPU. Scale up to that retailer in China with 400 cameras in a store. Now you can land several Xeons and FPGAs, and you can handle that giant workload. Here's a few of the markets and opportunities that we're working with our partners here in Taiwan on. In public sector, way better traffic control, emergency response, the ability to control traffic flow to allow the emergency response to be more timely to the scene of the accident. In financial services and banking, using the technology to minimize wait time, to ensure efficient flow of people and use of resources. In manufacturing, we saw the video talking about defect inspection. It's really critical. As companies wrestle with, or countries wrestle with, how do I keep my workforce employed? How do I make sure my manufacturing sector is healthy? Bringing these new technologies and these new capabilities to bear are going to be critical for that long-term effectiveness. Advances in these technologies are landing in casinos, in transportation, retail I've talked about, robotics, drones. Really, there's no sector, there's no space within the IoT, the overall IoT span, which isn't going to be profoundly changed through the deployment of AI and analytics.
When it comes to transforming your business, Intel delivers purpose-built technologies and market-ready solutions that provide real-time insights when and where you need them most. And with speedier deployments, consolidated systems, and a built-in foundation of security, you'll find smarter ways of doing business by gaining intelligence from the data of things. In stores, vision technology and robotics help keep track of everything and notify the warehouse what's in and out of stock, so sales associates can use insights to deliver better in-store experiences. Smart cameras are helping factories keep things moving by spotting defective products, unsafe situations, and potential machine meltdowns before they become a real problem. And when it comes to helping improve city life, it's possible to monitor things like traffic and air quality to keep everything running smoothly. The future of your business relies on data. So put your data to work with intelligent solutions based on Intel and start transforming everything today.
I'm going to throw a few things out here quickly that you might surprise you. Who would believe that you'd have robots roaming up and down the aisles of a Walmart store, scanning the shelves and measuring inventory during the day while the store is open and shoppers are there? Robots that can cost up to $100,000 each. It seems like a fantasy. You'll have over 600 Walmarts this year with those robots in them. Drones delivering packages. I remember seeing the very first television commercial from Pizza Hut. It was on a Super Bowl years ago, promoting that they were testing drones to deliver pizzas. And I thought it was the funniest thing in the world. We just learned now that they're actually testing here using drones to deliver coffee. Like, who would have thought that's real? It's actually real. Autonomous vehicles delivering groceries and delivering packages. In Phoenix, Arizona, where I live, we have 2 zip codes now where Kroger, big, very large grocery chain in the US, is testing autonomous vehicle delivery, driverless delivery of groceries to your home. These technologies are real. They're happening now. 400 cameras, high-def video cameras in a store. Amazon, Jeff Bezos, has said that they're going to have over 1,000 cameras in every Whole Foods. We're talking about a ridiculous amount of data that needs to be processed. I'm going to talk next about a couple demos, or a couple solutions, I should say, that we have downstairs in our demo center. These are real production solutions. The first one is AOpen and Meld CX. This one's fantastic. One of the problems you have is in grocery, they would like to have customers weigh the product and put the barcode on it, or self-checkout. In this case, the business challenge is King Nuts, a nut supplier, wholesale nut supplier to grocery in Southeast Asia and Australia, was having $800,000 a month of loss in nuts, where consumers were putting the wrong code in the system for the nuts. So maybe they're putting macadamia nuts on the scale, and they punch in the code for peanuts, maybe by accident, maybe because peanuts are a lot cheaper. But they were having a lot of losses because of this. Now, for a lot of customers, they're honest. I'm an honest customer. It's a pain to try to look up the code or remember the code. You put the nuts in the bag, you walk back over to the scale. What was the code? I forgot. Then you got to walk back over to the bin, find the code, punch the code in for the nuts. With this system, simple camera on top. They're using a Mobidius accelerator and Intel's OpenVINO toolkit. And the camera can detect exactly what nuts are on the scale And if the nuts are mixed, like in this package example, it can detect the percentage of each nut and price the package appropriately. So now you put the product on the scale, it automatically detects, it puts the code in, and prints out the barcode, and away you go. So better service for the honest customer, and for the dishonest customer, they're able to stop that fraud. Real solution live today. Next one to take a look at, Nextcobit. They've tapped into a really big trend, and this is for self-checkout or again, consumer-led checkout systems. In this case, you don't have to fuss with barcodes and scanning and the kind of traditional checkout process. This one's using cameras and a smart self-checkout. Their solution uses accurate facial recognition, so if it's for loyalty customers. You walk up, you've registered your face, you're a loyal customer, it detects your face, and then it allows a much easier and more seamless checkout process. This one's using an Intel i5 processor, an OpenVINO, and again, it makes this checkout process much simpler, easier, and more seamless for customers. Now, the focus for us at Intel, and I think the focus for you as an ecosystem, really needs to be on not just building a box, not just at Intel building a chip, but how do we take all these technologies that are maturing rapidly, and how do we bring these technologies to the market in a way that it's going to solve a real business problem? So in this case, taking the friction out for a shopper. In the previous example of weighing the nuts on the scale, taking the friction out for the shopper. In the case of those 2 million factories in China with no data, no analytics whatsoever, how do we go bring our technology solutions to those markets and show them how these technologies can solve real business problems for them? So with that, really, this is about how do we, as an industry, bring the right products together? How do we, as an ecosystem, collaborate together, whether it's ISVs, SIs, hardware platform providers, ingredient suppliers like Intel, and how do we bring the right vertical business knowledge and understanding to achieve that $33 billion incremental TAM that we talked about? Massive opportunity. We should all be super excited and thrilled. And with that, thank you for giving me the opportunity.
And thank you, Mr. Joe Jensen, for joining us this afternoon. And the next speaker will be Mike Gibson, Vice President, Threat and Vulnerability Research, Trend Micro. Mike Gibson focuses on threat discovery, analysis, disclosure, and protection programs at Trend Micro. He has over 15 years of information security experience, encompassing vulnerability and threat research, security operations, security assessment, and testing, to name a few. Today, he will talk about vulnerability management in a connected world. Let's welcome Mike Gibson.
Thank you very much. First off, thank you for having me here at COMPUTEX. Unlike Joe, this is only my first COMPUTEX, so hopefully it won't be the last. I hope to get to participate in many more. Ideally get to maybe 20 like him. In my role at Trend Micro, I get an opportunity to travel around and talk to many organizations about security. And one question that comes up very often from them to me is, in your role as Vice President of Threat and Vulnerability Research, what keeps you up at night? And my answer recently has almost always been IoT security challenges. And in particular, there are three specific challenges that really are a focus for us here at Trend Micro. One is the discovery of new vulnerabilities, being able to identify vulnerabilities in connected devices. Secondly, being able to then have a relationship with the vendor and disclose that vulnerability and be able to share with them the details so that they can get it resolved. And thirdly, the remediation of the vulnerability, being able to deploy the fix or a strategy around being able to address that vulnerability. And before I dig into each one of these in detail, I just wanted to kind of level set around what does the vulnerability lifecycle look like for us? How do we perceive it here at Trend Micro? And before I've made this mistake before, jumping in a little bit too fast. Can I just get a show of hands of how many people are familiar with what a vulnerability is in this context? Okay, there's only a few hands, so I better cover that first. In the context that I'm talking about today, what I mean by vulnerability is basically it's a weakness in a system that when accidentally triggered or purposely exploited will cause that system to basically have a trigger in some way and have that will override the security policy of that system. So in other words, it's a way for somebody to leverage or use a system in a way that wasn't originally intended, and typically to override security as a result. Make sense? So to look at the life cycle of a vulnerability, or how we look at it, it all begins with vulnerability, the day that the vulnerability is discovered. So either somebody intentionally, a security researcher looking for vulnerabilities, identifies something in the application or the system, or there could be a user that is using the system and accidentally stumbles across something. And this happened, it used to happen a lot more frequently. It's rare now, but there are opportunities where somebody is just using the system, using the application in a way where they take an action and boom, you see some unexpected behavior. And ideally, what happens after a vulnerability is discovered is that the vendor is notified. They're made aware that this vulnerability exists in their system so that they can go and take action on it. And then we move into this vendor response window, and it's typically around 120 days for us, where we're communicating back and forth with the vendor, making them aware of the details, understanding all of the ins and outs of the vulnerability so that they can come up with some kind of remediation strategy for it. And then the vulnerability is either patched, or in some cases it'll remain unfixed, and that's typically because legacy systems or the issue is too complicated to actually release a patch. After the vulnerability is patched, then the public becomes aware of it. That's when public disclosure happens. That's when the researcher is able to openly talk about this vulnerability and share the details. And ideally, that is also when a patch or fix gets applied by the customer. So they'll take whatever patch has been made available by the vendor and start to apply it on the vulnerable systems in their environment. Okay. All right. Now that we've covered that, I want to talk a little bit about the first area of challenge that we see related to connected devices, and that's in the discovery of new vulnerabilities. So if you look at this chart, this is the number of vulnerabilities that are reported per year based on the source of MITRE, and they track out many different vulnerabilities. And you can see there's definitely a pretty significant uptick for 2017 and 2018. We attribute this to the fact that more and more software organizations are opening up bug bounty programs. They're engaging with the research community. They're rewarding people for helping identify defects in their software and get them reported so that they can get them fixed. And overall, I think that's a really good thing. The overall number can be a little concerning, how it's spiked, and the fact that there's that number of vulnerabilities out there. But what I take as a positive in this chart is that we're doing more and more as a community to actually find and fix these things. However, if I look at a subset of this number of vulnerabilities, and this is the number of vulnerabilities that reference ICS CERT. And I chose the ICS CERT because it's an organization that basically facilitates the disclosure of vulnerabilities related to critical infrastructure. But they don't only do that, they will also facilitate disclosure of vulnerabilities around connected devices, things like medical devices, connected medical devices. And so at Trend Micro, whenever we find or identify a vulnerability in a connected device or an IoT device, we will then try to disclose it through ICS CERT, and they will work directly with the vendor. And so we use this kind of as a way of identifying the number of vulnerabilities that are related to connected devices, one way anyway. And you can see that while it's definitely trending in the right direction, the fact that only 419 out of 21,000 plus vulnerabilities were disclosed had a reference to an ICS CERT disclosure, that I find very concerning. I think we can be doing a better job finding vulnerabilities in connected devices. Another area that concerns me is the type of research we're doing when it comes to connected devices. Here we have 3 examples of research that Trend Micro participated in. The first is an example where we had some research into Crestron devices where we identified an ability to remotely activate the camera or the microphone in these devices, which would enable you to kind of spy on meetings or listen in on meetings or record conversations that happen in meetings. The second one was with a satellite TV provider in the US, where our researchers were able to inject video content. So you hear a lot about fake news these days. In this case, our researchers were actually able to take a news station and play whatever content they wanted to, whatever video content they wanted to on that station, making it appear to the end user like they were actually watching CNN or CNBC, etc. The third one is an example where the researcher was able to basically hijack a drone. So one of, person normally out flying a drone, taking pictures, taking video, whatever, he's able to come along and just stand in the proximity of that original operator and hijack the drone immediately. And where that's interesting is, the FAA has recently given permission to CNN to fly drones over crowds. And potentially some of these devices, we just heard about drones being used to deliver packages. Potentially some of these devices could be susceptible to hijacking or interception like this. So we've done some research in this area. And I think this is all fantastic research, but where I am a little concerned is that all of these devices that were tested in this case can all be acquired by a researcher for, less than $1,000 US. So it's all pretty readily available to the research community, and most of the research you see in connected devices falls into this category of fairly inexpensive equipment. But what do we do when we want to identify vulnerabilities in a device like this, an MRI? It gets a little more challenging for the research community. I talked to many CISOs of healthcare organizations in the US, and almost all of them will agree that connected medical devices are a huge security concern of theirs. And they realize that there's not a lot of people looking at identifying where vulnerabilities might exist in these devices and helping remediate them. Another example is manufacturing. In this picture, there are many different connected devices, even that little light. Luckily, it's inexpensive enough that we've done some research into that light, and there are also vulnerabilities in that tiny light, just with the red, yellow, and green. And most of these devices aren't accessible to the security research community, so they're not able to actually test and help identify some of these things and help get them remediated. I was, for example, I recently toured a manufacturing facility in Northern Ontario in Canada, and I'm walking through the facility with the Vice President of Operations there, and he's showing me how they're going through a modernization of their manufacturing facility. And we're kind of walking up, and he's showcasing this and that machine, and he wanted to show me this his baby, this brand new machine, multi-million-dollar piece of manufacturing equipment. And I asked, is it okay if I go up and kind of take a closer look? And he said, sure. And I walk up and I touch the keyboard, and the first thing that comes up on the screen is Windows XP. So this is about a year ago, and this thing arrived with an operating system that has been end of life for multiple years. And so I asked him, I said, hey, how long do you expect, what's the expected life of this device within your environment? He said, well, we hope to run it for 15 to 20 years. So an operating system that is already end of life the day it arrived is most likely going to continue to exist inside his infrastructure for the next 15 to 20 years. And there's no security patches available for this. There's nothing they can do if new vulnerabilities are identified. And so when it comes to connected devices, these are definitely challenges that organizations face. But it's not all doom and gloom. I wanted to highlight one company that we've done some work with that is kind of forward-thinking when it comes to security, and that's Tesla. Tesla already had a very good bug bounty program. They already were well engaged with the security community, trying to encourage people to do research on their vehicles, find areas for improvement, find opportunities where security deficiencies could exist. However, they still approached us about an event, our Pondone event that we hold twice a year, this one being in Vancouver, and they wanted to see if they could participate in that event. Pondone for us is an event run by our zero-day initiative team. And what it is we give an opportunity to bring researchers together to demonstrate their ability to exploit enterprise applications, devices, et cetera. We basically create a target list for the event, and we encourage people to do their research against those targets, and then come and demonstrate to us their ability to exploit, to take advantage of vulnerabilities. And so Tesla wanted to participate at Pondone in Vancouver, and sure enough, 2 researchers showed up, and they were able to successfully exploit the browser that's running inside the Tesla, and then, therefore, they were able to take home a cash prize, and they were also able to take home the car. And it was super impressive. But also, what I really liked about it is the fact that these 2 security researchers now have a Tesla in their possession, so you can be sure that they're using this for more security research when they're not just joyriding around. All right, the next area I wanted to talk about was vulnerability disclosure. So we at Trend believe strongly in coordinated vulnerability disclosure. And what that is at the point where we're able to identify a vulnerability in an application, a device, a system, and we engage with the vendor, we don't want them to get defensive or see us as the enemy. We want to work together with them, share the details we know about, have them understand fully that we're just trying to help fix a gap in their system, and then also even offer our assistance to test anything that they come up with for mitigation or for patch. And so it's really a two-way conversation. It's well coordinated. We agree not to talk about the vulnerability publicly until they're able to address it, and so forth. However, and in the enterprise software world, this has been working very well for many, many years, probably a decade or longer. Most organizations believe in coordinated vulnerability disclosure. They'll document it. They'll talk about openly on their website how you go about disclosing vulnerabilities with them. But in the connected device world, we are still seeing that we get a little bit of this result. We get redirected to the legal department. They're not really sure what a CVE or vulnerability is. They're not really sure how to engage with the research community. They see us as, the enemy. They see us as trying to exploit them or trying to take advantage of them in some way, when really what we're hoping for is just to get that vulnerability closed for the end customer. And so we definitely want to encourage organizations to really not take this stance. You can involve your legal team if you feel like that's necessary, but really what we're trying to do is really the best thing for your customers and our customers. The third area is around remediation. So I don't need to talk to all of you about the number of billions of connected devices. I think that Joe just presented on how they're enabling more and more connected devices to be built. I think this is a given. This number is going to continue to increase significantly. But it does create unique challenges when it comes to the remediation of vulnerabilities that are identified in these connected devices. If I use my own home as an example, so I've got a family of 4, my wife, 2 daughters. And in our home, we have a couple of MacBooks, a couple of iPads, a couple of iPhones. And from me being the IT guy at home, being able to maintain those and keep up to date with software and all of that, that's pretty easy. That's kind of common stuff that we all do. But I also consider myself living in a smart home. And so if I take into account the doorbells, the cameras, the door locks, the thermostats, the smoke alarms, smoke detectors, all of these connected devices, we're probably nearing 100 connected devices in our home. And the idea of me, even as a security professional, trying to monitor firmware updates and software updates and all of these things for all these devices within my home, it would just be overwhelming. It would be a headache. And so some of them are very good. Some of them will update themselves and you can turn it into that mode, but not all of them. And this is where, if I'm concerned about security, I need to do this activity myself, and it's extremely difficult. Also, if we flash back to the manufacturing example, for that VP of operations I was walking around with, for him to consider taking a piece of manufacturing equipment offline for maintenance for a software update, that means lost revenue. That means that machine is no longer operational for them. And rightfully so, more times than not, they're going to choose to just run with outdated software versus taking a machine offline because it's generating revenue for them. Same with the hospital scenario. These medical devices are helping patients. They're helping keep people alive. They're monitoring them while they're at the hospital. If they have to rotate those devices out of circulation, that's time where they're not available to help patients. And of course, the hospital is always going to choose patients and the health of their patients over software updates for medical devices. And so there are a lot of challenges when it comes to the remediation or patching when it comes to connected devices. People are often going to stay on older versions, even though they understand that introduces risk into their environment. And so, what's the real world impact of this today? Well, we see a lot of botnets pop up there's probably been over a million, easily over a million devices that have been exploited through different botnets or different pieces of malware that are just being used to launch distributed denial of service attacks. Yeah, it can be a problem, but for the most part, it's not a significant challenge for us in the security industry or for our day-to-day operations. There are things like BrickerBot, which is like destructive malware. Its intent is to do nothing more than to destroy the hardware that it's being able to exploit. And you know what, to be honest, for cyber criminals, there's not a whole lot of money in destroying devices, so this isn't really a top priority for them. I bring up ransomware and WannaCry specifically because it didn't target connected devices specifically, but because those devices were running a similar software stack as, say, PCs or the other infrastructure that was targeted, they became collateral damage when it comes to the spread of a worm like WannaCry. And so, these are serious problems for sure. I don't want to downplay them, but I don't think we've seen any very serious attack or threat related to connected devices yet. We talked a little bit of, the AI is obviously an important theme here. And think of the scenario where an attacker is using AI and they've been able to exploit cameras and microphones and all of this stuff inside your home, and they're leveraging AI to listen in, to watch video, to see different areas where it can exploit you. And obviously they can't do that at scale with a human being. So they're able to develop algorithms and use AI to determine when you said something that could be used to exploit you, when you may have did something or taken an action on a camera that could be used to exploit you and used to extract ransomware from you, or to extract a ransom from you. So I think we're going to see some interesting attacks. I don't think at this point the bad guys have really figured out how to monetize exploitation of connected devices. And so, my recommendations in summary for manufacturers: one, make sure you leverage the free energy of the security research community. There are a lot of researchers out there that'll work for nothing more than an acknowledgement on a web page. They just want to be they want to help you solve your security challenges. Try to find a way to make that easier for them to do so. Try to find opportunities to get access to your technologies so that they can go and do this. Secondly, make sure you establish policies and procedures for coordinated disclosure. Make sure that you don't see a researcher as the bad guy. They're not trying to take advantage of you, and they're not trying to go public with information and make you look bad. They're really ultimately there just to help you secure your devices and help you close some of these security vulnerabilities. But at the same time, again, they're really just looking for acknowledgement that they did that hard work and that they shared it with you. And third, ensure your products can be easily updated and patched. When we get into this world of billions and billions of connected devices, make sure that there's an opportunity for customers to easily manage those, because relying on them to manually touch all these devices and update them, it's just not going to happen, especially as it grows and grows. And so, if anybody ever needs any help with any of these items, feel free to reach out to Trend Micro. We offer free services to be able to share some of our best practices around this with you if you're not familiar with how vulnerability disclosure happens or how it works. And then for consumers and businesses, make sure you do your due diligence. So now when I'm looking at devices for our business or for me personally, I want to make sure that the manufacturers that I'm purchasing from understand security. They have a page on their website that talks about the way they approach security. They have a formalized product security incident response team that can address vulnerabilities, respond to vulnerabilities. The products are able to be updated and patched. There's many choices out there, and if you have to choose, make sure you choose one that takes security seriously. And with that, I just want to say thank you again, and that's it.
And thank you, Mr. Mike Gibson, for joining us and sharing with us your insights. And the next keynote speaker will be Dennis Cabral, Executive Director and General Manager of IoT and Security Solutions at NXP Semiconductors. Dennis Cabral leads the solutions organization at NXP and is responsible for combining leading technologies such as machine learning, edge computing, and security into new groundbreaking applications. Today, he will talk about machine learning and AI at the edge. Ladies and gentlemen, please welcome Dennis Cabral.
Good afternoon. It's a pleasure to be here in Taipei today. The subject we're going to talk about today is basically the changes that's happening of where the intelligence is happening on devices. And to talk about that, the most important thing I will talk about is where are decision-making happening on devices when there were all devices, local intelligence happening locally, then connection to the cloud, and then how now we have hybrid systems where intelligence is shared between the edge, which is the end device, and the cloud. So I work for NXP, just a little overview of which company we are. So we are a semiconductor vendor. We work in about 30 countries. The bulk of our revenue is coming from automotive products as well as IoT, payment systems, and connected devices. So what we see here is basically a very important shift in the volume of application shipping. You can see here for the last 40 years that we started with mainframe computers, mini computers, PCs, cell phones. Now basically everybody in the world has a cell phone, so the market is tapped. So you can see here the growth of cell phone is plateauing and starting to decline because everybody's got a cell phone and you know how to change it every year. But what we see here is that the IoT devices, the small devices that are in every home, and they could be 10, 20, 13-inch home, are growing very rapidly. And the value of these devices really depends on how intelligent they are, because we don't want to have to deal with all these small devices with their own little user interfaces. They need to be transparent to the users. And this is why making them intelligent, making them able to do things without having us to think about it is very important. So now, maybe 20 years ago, every device was independent. There was a small microprocessor, a small microcontroller on these devices. They had to make their own decision by themselves. And so you had a pretty limited intelligence because of the cost of these devices. You couldn't put a high-end processor on each of these devices because of cost, because of power, because of size. And then what happened is the cloud happened, right? The cloud happened and people think, okay, well now the device doesn't need to be intelligent because it's going to be connected to the cloud, and the cloud has infinite computing, infinite storage, authentication, all these capabilities here. So the device here is a connected device, but basically the intelligence doesn't reside on the device. It relies on the cloud. And that created a bunch of limitations. The first of all being, what happens if the connection is lost? Well, now you have this brick here. The device doesn't do anything. No connection. Sorry, can't do anything. You could have privacy issue. Oh, I'm sending all my data to this cloud provider. What's going to happen with my personal information here? You could have latency issue, right? You're driving a car. It needs to be autonomous. You can't wait for the cloud to respond to make decisions. You could have issues of cost, right? If you send all your data to the cloud, well, there's lots of connectivity cost and cloud costs associated with it. So what we've seen in the last few years is this trend of edge computing, right? What is that? Well, it's basically saying the device here are going to depend on the cloud for some of their capabilities, but a lot of the intelligence is going to be built locally on the device, right? And so things like sensing, of course, was there, but the processing, the safety, the security, the connectivity, right? Because now your device is connected, it needs to be secure. It can be attacked from the cloud. It can be attacked through the connectivity. You need to make sure all these things are in there. And so you have this balancing act of where is the intelligence going to be? Is it going to be entirely in the cloud, entirely in the device? And what we're saying here is that actually there is always a good trade-off between having some of the local intelligence on the device and some intelligence in the cloud. And basically what I'm going to be talking about today is a few examples of how we decide where this intelligence needs to reside with some of the solutions we'll be building in NXP. So everything I mentioned here targets basically all the markets we've been working on. Automotive, right? So of course, automotive is the car is the ultimate edge node. A lot of local processing, a lot of autonomous capabilities, but also a lot of dependency on the cloud for things like autonomous driving, for things like map making, connection, etc. Industrial and IoT, Industry 4.0 is a great example here, right? The devices need to connect together. They need to work together in the new factories. Mobile, we know that already. Your device now, a few years ago, you had an app, and if there's no connectivity, your app is not working. Now, most apps are able to do a lot of things, even if the connection is not there. They store your data. They're able to do some basic functionalities, even though they depend on the cloud for some of the functions. And communication infrastructure would push all these things together, right? So I'm going to be talking about all these capabilities in the middle that are the edge computing capabilities that make the device very smart combined with the cloud. Again, I'm not advocating here that devices need to be independent of the cloud. What I'm saying is that there is a good balancing between the edge computing capability and the cloud infrastructure. What kind of capabilities are we talking about here that are based on local processing, right? Well, voice processing is an example here, right? When you talk to your smart speaker, your voice is not constantly, the noise in your room is not constantly streamed to the cloud. The device is locally intelligent enough to decide, am I being talked to decide that now you're actually addressing the device with a trigger word, and then streaming the data to the cloud. We are working on solutions that will enable you to give specific instruction to your device, like turn on my lights, increase the temperature, etc., without relying on the cloud, because these are more private kind of information. Still rely on the cloud for things like, book a plane ticket for me or add something on my shopping list. So here, a balancing what's done locally or in the cloud. Gesture control, something else that does a lot of processing locally. You don't need to send everything to the cloud, but then when the decision has been made of what you're actually trying to do, send information to the cloud. And there's a bunch of other use cases here that rely on a good balancing between cloud processing and device processing. So give you a few examples here of things that are already heading the market right now. Autonomous driving, right? Driver monitoring. Is the driver being intoxicated? Is he falling asleep? Is he paying attention, right? Rely on local monitoring as well as cloud connectivity. Smart doorbell, that's something else, right? You don't want all your information, your private information, to be sent to the cloud, but when something happens, something is detected that is abnormal, then we depend on the cloud connectivity to bring more intelligence to the device. Personal assistance, I already mentioned that one. And then applications that are ramping up, right? I am a big fan of this anomaly detection example here, right? So you have this device that's out there in the field. It's a motor, it's a pump, it's something that's operating, and you're constantly monitoring that device for any kind of failure. Now, you may be getting mega samples of data. You maybe have accelerometers, sensors, etc. Do you want to ship all that for the 20 years of the device to your Amazon cloud, your Microsoft cloud, etc.? No, you don't. That would cost you a ton of money, a lot more actually than the end device itself. So what you want to do is local processing. I will show you an example of that in the rest of the presentation. Alarm analytics, right? So you may have seen that this feature has just been enabled, for instance, on Alexa smart speakers, where basically when you're away from home, you basically tell the speaker you're getting away, and it will detect any kind of strange noise in your house and be able to alert security services, for instance, right? So another case where the device is constantly locally measuring what's going on and then connects when something happens. So here I'm showing you a few subjects where NXP is working on these kind of use cases. The first one is our EIQ machine learning enablement. So here the first idea is, how do you make the local device local? Well, very local device intelligence. Very often you have some kind of a neural network model or a machine learning model, and that thing works great on a PC, it works great on the cloud, but you're wondering, okay, now I need to make that run on an MCU or a microprocessor. So a device that has a lot less resources than what you would have on the cloud. So our EIQ machine learning enablement tool is basically helping you port any kind of standard machine learning framework working on the cloud and making work on our microcontrollers or our microprocessors. So optimization of the code for running locally in a device. The second thing is our edge-scale solution here, which is basically how you use Docker containers to enable some of the machine learning capabilities on the device. So how do you basically take the stuff on the cloud and port it, make it run on your IMX or Linux kind of processor? Here we also have boards or solutions working with our partner. The first one is the Google Coral development board that works on our IMX 8M. Development kits with Alexa, for instance, also running on IMX 8M. Our development tools with Ozone. So here, this is how we as partner silicon vendors are working with other players in the industry to bring the right solutions to market. And finally, I mean, this stuff here at the bottom is actually coming directly from my team, is our turnkey solution. So basically, these are solutions where all the software, all the hardware is already being designed, and you can very easily create an Alexa voice solution on an MCU or an application processor with all the code being available from us, fully tested. And I will show you what we're doing here on this anomaly detection solution right there. So here the idea for our customers is, of course, you could do everything yourself. You could design this whole thing, but we are providing something that enables you to go to market extremely fast. So EIQ, right? That's one of the first thing I presented before, right? The idea is you can take any of these machine learning things, right? All these inference engine, all these libraries that are very easy to work on in the cloud, and through EIQ, you can use the hardware, the processors, the DSPs, the GPUs, the machine learning accelerator that are on our chips, and port it on a very entry-level sub-$5 IMX RT processor, all the way up to our layer-scale processor. So basically here is a tool on how you use machine learning on embedded, local, low-cost processors. NXP also has a lot of local R&D resources based in Asia right now, working on machine learning. And these are a few examples of the things that I've been working on, from payment terminal, object detection capability, identification through the veins in the hand, object recognition, audio processing, voice recognition, secure access capabilities, all these things being designed by NXP locally in Asia, enabling local device and cloud combined capabilities. And here I wanted to give you two examples. One will be around preventive maintenance and the other one around voice. So this is something that we announced 3 weeks ago at the Build conference with Microsoft. And basically, this is a shared capability to do preventive maintenance using local processing as well as cloud. So what is this? Well, basically, what we've provided is a very simple hardware board here. That board is about 4 centimeters by 3 centimeters, and that board is loaded with sensors. So you can see right there, we have microphones, we have accelerometers, we have gyros, magnetometer, air quality sensors, etc. The idea is basically whatever you want to measure, we have a sensor on this. Now, what are our customers going to do with this? They're going to take it, they're going to simplify it. They will just keep the sensors that they really need in their application. Now, you can see here, this is a sandwich board. There is a board on top, and there is another board at the bottom here. That board here contains the processing unit, which is this IMX RT MCU. This is a Cortex M7 processor, well below $5 in terms of cost. It has flash. It has an option for more DRAM if you need more capabilities, but the device itself has a megabyte of SRAM on chip. So for many use cases, you don't need that. It has a connectivity module for Wi-Fi, so basically connecting to the cloud. It has a Zigbee and Thread module, which basically enables the devices to talk between each other. And what do we do with this? Well, the first thing we can do is a completely local machine learning exercise. No cloud, no connectivity. What is that for? Well, basically, that device here, the IMX RT, can pull the data for any of these sensors, create a local model of normality. So basically, suppose you take that sensor, you attach it to a rotating device, a pump, a compressor, a machine. You don't need to know what that device does. You don't need to know what is the normal model. Basically, you attach it to it, and you let that device learn for a full day how is this device operating. So it will learn the vibration of the device. It will learn how, during the day it operates, etc. And you create this model. And this model here is these pink triangles right there. They define a cloud of points that are the normal operation of that device. So basically, you don't need to do that in your factory. You don't need to make it differently for every device you manufacture. You basically attach that sensor to that device in the field. And it can be a brownfield deployment. The device can have different kind of use cases. One can be on a hard floor, and it will vibrate one way. One can be on a squishy floor, and it will vibrate a different. It doesn't matter. It just learns how the device normally operates. And then you put the device into running mode. And in running mode, what's going to happen is that it's going to start comparing that normal mode, that normal operation to what it sees. It will see a slow variation because of the device is wearing out. And at some point, the bearings will start to go wrong, or the device will start to get out of balance. And then you're going to see these models, these points out there, the red points, right? So as long as the points stay within this boundary here, everything's fine. As soon as you start to see points coming out of that boundary, you know that this device is not operating the way it used to be. And here, basically, the device can learn completely locally about the normal and non-normal point. And at that point, you can decide to send a technician, you can decide to shut down the device immediately, you can decide to send a message to the cloud saying, hey, you know, this is weird here, what's going on? You can have somebody look at the data, but this is a completely standalone interaction. Moving forward, we think, oh, okay, so here the device has some capabilities to detect if something is normal, something is not normal, but maybe you want to do more with the data. Maybe you have thousands of these devices and you want to learn more. Well, now you connect that device through Wi-Fi to the Azure IoT hub. So we've basically put the Azure low-level connectivity on our board here. And you stream the data, so that's the other extreme. Now you're going to stream all the data to the cloud. You're going to say, this device is dumb, it's just aggregating data, send everything to the cloud. And the cloud will do the machine learning, it will learn, and it will be able to detect if the device is operating normally or not. That also is not the best use case, because now, suppose this is an accelerometer, you get a mega sample per second, you're going to be constantly streaming a boatload of useless data to the cloud. It's going to cost you a lot of money. If the device is far away in the field, this is going to go to cellular connectivity, it's going to cost you a lot of money again. And it's not the right thing to do, because most of this data is garbage. It's just, it's working fine, it's vibrating as usual. So really what we're advocating here is a solution that's a hybrid approach. The local microcontroller, the microprocessor on this board, is able to detect 99.99% of the use cases. Basically, as long as the device is operating more or less normally, you don't do nothing. You just send a message every hour saying, hey, I'm fine, don't need any help, thank you very much. When the device detects that the data points are outside of that cloud of normality, now you don't know. Maybe somebody kicked the device. Maybe it's raining. Maybe, I don't know. Maybe there's a power fluctuation. Maybe it's nothing bad, right? Or maybe that thing is going to blow up, right? If this is an oil pump, you can imagine what can happen. If this is an engine, you can imagine what happened. So here what happens is that the device is able to basically say, something is unusual here. I'm not smart enough to decide. Now I'm starting to stream all the data to the cloud. So first of all, what's going to happen is the device is going to connect. It's going to upload all its cache. So basically all the information that led to this decision saying something is weird, upload it to the cloud. And from there on, stream the data until some decision has been made. And now on the cloud, you have a lot more power, right? A lot more storage, a lot more computing. You can compare different devices in the same area to see if they see the same thing, for instance, and you can make a much more educated decision. So here, basically, in summarize, right? We have here a screen that shows all the devices connected, the storage of the data. You have a power business model here, so basically the user out there can compare what's happening with each different devices and can quickly come to a conclusion, do I need to send a technician, or is this just a fluke in the system, no problem, right? So again, main point here is the right segmentation of intelligence between the local device and the cloud can enable a very low cost, sub $10 system right there to basically save you a ton of money from cloud processing, connectivity, et cetera, still giving you a state-of-the-art system in terms of failure prevention. And this is an example of basically a model of what the operator will see in the cloud. So this has been a partnership that we've done with Microsoft, and that device, that use case here, will be released to the market in Q3. Second case, that's something that we've announced at Embedded World. in Germany in March. This is the world first MCU solution for voice control with Alexa. Why did I decide to show this one? It's this exact same case. It basically shows how much of the processing can be done locally in the device and how much goes in the cloud. So this is a reference design that we've built. It's also built on an IMXRT, which is a low-cost, low-power microcontroller. It is the first solution in the market that does full voice processing on an MCU. I don't know if you guys are familiar with MCU and MPU, but an MCU basically is a microprocessor that's in one chip, including the memory, including basically everything you need. It doesn't need Linux, it doesn't need external DRAM, it doesn't need a lot of external flash, so it is a much lower cost model than an MPU. Basically today, Google Assistant, Alexa speakers, etc., all these voice capabilities depend on MPU running Linux, which has a much higher BOM cost than an MCU solution. So the goal really here was to achieve a lower cost by doing a different partitioning of the intelligence being done locally and in the cloud. I will also show you that this is a turnkey design. So what is Alexa built-in? This is an Alexa built-in solution. So Alexa built-in basically means that the device has microphones on itself. It's able to listen to your voice and make decisions based on the local voice reception on that device. Contrasting it to works with Alexa, which is basically this device is able to receive commands from the cloud, from Alexa, but it doesn't have microphones. So basically it's just an actuator controlled by the cloud. So here we have a full voice capability built in the device. What does this go into? This is not about making another smart speaker or another high-end device. This is about integrating voice capability in any end equipment. You can think about a fan, appliances, et cetera, et cetera. So a lot of use cases here where intelligence can be added into the local device. And this is a comparison of the BOM cost of an MCU versus an MPU. So you can see in there, right, the column in the middle is how it's done traditionally. Traditionally, you're going to have a processor, you have an audio DSP, you have a large amount of memory because you're running Linux, you have a large amount of RAM and flash, and when you contrast that to how you do it with an MCU, I mean, not only is the processor cost lower, but really you're saving a ton of money on the DSP, which you don't need, a lot cheaper memories out there, and no PMIC. So you can see here, right, there's basically a ratio of more than 2 between an MPU kind of BOM cost and MCU kind of BOM cost. And this is for typical distribution price. So this is not your million unit volume after negotiating with your suppliers. Oh, sorry, wrong direction. Did I get that right? Sorry, guys. I'm fumbling with the remote. Not enough local intelligence. So why do we call that a turnkey solution, right? First of all, it is completely optimized in terms of hardware, so you're not going to find a lot of extra components on this device. The second one is it completely works out of the box, right? We provide the entire software. It's a fully tested, fully documented piece of software. So for our customers, more or less, they don't need to understand how voice processing operates. They don't need to take care of the DSP stuff, the barging, the echo cancellation, all this stuff is already provided out of the box. It comes with security, it comes with upgrade capabilities, which are necessary today in modern devices. We fully document this stuff. We have support globally to do this. It's certified, both of FCC, but also for Amazon, which does a lot of extra testing in terms of voice capability. And it's today available from 4 or 5 different ODMs and OEM in China and in Taiwan. So basically, if you have an appliance, if you have any kind of devices where you want to add audio voice capability in it to control it, this is the solution you want to use. You're going to add less than $10 of BOM cost to your device to add this capability. And really the most important point here is about time to market. We have proven pass record right now with some of our partners starting this device in February, and they are now ramping production for release to the market in June. So here, a complex device with voice, echo cancellation, etc., from design to full production in less than 5 months. It's a really fast cycle time here. Okay, and so here, wanted to thank you for your time. I want to make sure that You understand now how to make decisions between designing devices that depend entirely on the cloud, local intelligence, and what we think is the best thing to do here is to use the cloud as an extra capability, but still keeping a lot of the local intelligence on the device. Thank you very much.
And thank you, Mr. Dennis Cabral, for joining us this afternoon. And the next speaker will be Dr. Alan Yang, Chief Technology Officer of Advantech. Alan joined Advantech in 2014 and now leads the corporate CTO office. He is responsible for the design and development of WisePass Platform as a Service, an industrial IoT data platform aiming at extending Advantech's industrial computing platforms to data-driven, cloud infrastructure neutral, and AI-empowered cloud services. Without further ado, let's welcome Dr. Alan Yang.
Good afternoon. It's a great pleasure to have the opportunity to share what we have been doing with IoT combining with AI. My topic states that it's digital transformation, and the targeted audience actually is toward business, toward industry, toward where you are looking for technology, bringing technology to further improve the management efficiency, the business operation, or how you can leverage the power of data empowered by collecting through IoT communication and then extracting out of with AI. Since about 30 years ago, when the computation proliferated into the PC platform and gradually get adopted by enterprises, we started to see almost all corporates setting up IT departments, setting up their own data centers, setting up their machine rooms, and setting up their IT enterprise systems. That has been going on for some time. And on a parallel thread, we have witnessed that the operational side, we have been getting more and more automated, more and more sophisticated equipments to facilitate our technicians, to facilitate our operators to better improve their efficiency on their job. And in between the so-called the operation technology and the information technology, we still need a lot of professionals that running around in between the IT system and the OT system, trying to make the best judgment in response of that current business situation. Now, in the past several years, the consumer cloud technology has driven through a new breed of computational platform now called cloud-native architecture, which is not yet very much exploited by enterprises, all right? And with the data platform that we have been building, we call WisePass, we started introducing to many of our existing customers, and many of them feel strongly interested. And here is our opportunity to share this idea with all of you. Last year, November 1st and 2nd in Suzhou, China, Advantech hosted an IoT co-creation summit. We had roughly 6,000 participants, and over there, 100 talks, many demo booths, a lot of so-called workout meets. The turnout was actually better and more responsive and receptive than we anticipated. Among the participants, if we sort through the ecosystem of where they position in the value chain, there are many of the system integrators who have been doing automation for manufacturing sites, for hospitals, for wind farms, for solar farms, for retail businesses. They have been seeing that the customer will, are asking for fusion of automation and their IT systems. So with that, we see the need actually to leverage the proven effective cloud technology into the manufacturing, into the medical, into the retail, and the like sort of platforms. So we recommend many of our existing partners, whether they are our suppliers or our technology partners or our existing system integrator customers, to reflect on their current business positions and the value that they offer to their existing customers, and whether they decide to position themselves as either starting from the very left, they are the end business management user. They're basically running some sort of business. Either they are running a factory, or they're running a retail chain, or they're running a fleet. And with their existing technology, current technology, are they considering to bring in more intelligent solutions to further improve their management effectiveness? And starting from the very left, moving one layer to the right, is whether they are going to do the so-called digital transformation with their own in-house automation team or integration team, or they would like to invite external partnership, external help from the newly formed AI IoT system integrators, or the newly transformed existing enterprise IT system integrators, right? So that's from the second layer to the end business users. And for the system integrator, usually they would have to invest a lot to come up with the required technology module in order to approach their end customer. And when I say customer, I don't mean consumer customer, but business customer, industrial customers' need. They usually need to start finding building blocks of solutions, both in the form of hardware platforms. We have heard Intel, NXP introducing their edge intelligence either through a vision or a voice recognition. And there is actually a lot of other edge platform, a lot of edge data actually coming in the form of through industrial protocols. A lot of machine connected data are extracted out of existing long-running protocols. All right, so they would usually need so-called the edge solutions that bridge toward the brownfield of many legacy systems. Some of the equipment has been there for many years. Many years, I mean many years, like 10, 20, 30 years, and still running. Now, the customer would like to elevate the existing approach of managing all those assets with industrial IoT, and then hopefully also leveraging AI. So from the edge connectivity, then the best approach is to pair it up with a cloud-native data platform. Cloud-native data platform. We have tried to do industrial solutions in the reverse direction, starting actually from the end utility of our customer request, from the very end, and design the user interface, design the user flow, then derive the required business logic, and then derive the data structure and the information required to sustain the functions, and then specify the edge device that is required. After doing industrial solution in that way for a few years, we found out we got it wrong. Because once that system is set up, it immediately is cast in stone. It becomes a single-purpose system, and it's very hard to be revised or iterated toward a changing, evolving customers' demand. So we quickly change that architecture into a so-called data-driven architecture by bringing a cloud-native compute resource management framework, then collect as much data as the budget permits, and then segregate the data from how we visualize it, how we analyze it, how we institute a business policy, and how we extract the value out of the data. So WISE-PaaS is positioned at connecting to the edge platform, bringing in the data either through camera or through a voice or through a collection of different sensors, or more often is actually through industrial protocols of various type of equipments, then put it into a data platform, then specialize it into a particular industrial verticals. And of course, all these need compute resource, all right? And that compute resource, when I say cloud native, naturally we would refer to, say, the most popular leading cloud compute resource provider like AWS or Azure or Ali Cloud. And many of our customers, they are so sensitive about their data. For example, like hospitals, their data has to be kept on site, no matter what, all right? For some of the manufacturing customers, their recipes, the parameters of their processes, meaning hundreds of millions of dollars of revenues, by no way, regardless of how sincere the guarantee coming from these public cloud providers, assure them. Trust is not an issue. Business confidentiality is the issue. They are, by the way, they are going to put those sensitive data onto public cloud. So compute resource, often we run into the situation the customers strongly require, insist, no other way around. The data does not leave our premises. So we have to go with pure private cloud facility. Of course, when we talk about IoT, AI, and edge, all that, we need to put them together into addressing certain industrial verticals demand and create business, create revenue out of it. So Advantech has been focusing on targeting connected equipments by bringing the data, forming predictive analytics, improving the equipment's utilization and productivity and quality yield. That's one class of application. The second class of application is actually combining the equipment data into a production site, right? Various type of manufacturing facilities, right? So by improving the OT and IT and the personnel's domain know-how, technical experiences into the industrial 4.0 type of scenario, the second category. The third category is that many of the industrial customers that we deal with, they bring in Advantech's industrial PC embedded system in the field. And this field computer, they are actually shouldering mission-critical type of services. Any downtime, meaning interruption of business. They want to make sure that this industrial PC is reliably functioning, and they would love to know if these industrial computers are about to fail. So the third category of application we call device zone is actually managing the industrial edge, including predictive reliability capabilities. That's the third category. And the fourth category is that targeting many variety of service sites. For example, like hospitals, right? Like airports, like train stations, or shopping malls. The traffic of the customer, the service quality to this customer on that site needs to be managed over all the entire field. We refer that to as command center for service sites, right? So that's the fourth category. And as I just have described, some of the business category, they strictly insist on data not leaving their own premises. So private cloud is a must. And then we also work with a lot of customers targeting many other type of industrial IoT scenario, like smart street light, like smart parking, all right, like fleet management, like, as I mentioned, energy and environment type of services. So these are the targeted application scenario that we would like to fulfill. And they appear to be a very diverse set of applications. So we try to adapt the so-called data-driven type of architecture design. And this is one example toward factory and Industry 4.0. And at the bottom, you heard about edge intelligence. And then at the top, you heard about cloud services. So at the edge is a lot of different type of edge connectivity, dealing with extremely fragmented industrial protocols. Then in between this layer is actually, it's actually a cloud-native data platform that we put together, right? And it basically deals with a scalable data infrastructure dealing with different type of data, either SQL, NoSQL, time series, blob, in-memory type of different sort of data in a scalable way. And at the second layer of this data platform are three main services, offering visualization, offering asset performance management, and offering AI framework services. And on top are the domain-specific application that we offer or our partner offer toward addressing improving the production size productivity through AIoT. So this is one type of architecture. Targeting energy and environment. Energy and environment, you would immediately think about a very widespread geographical locations. Windmill, solar farms, oil rigs. It's actually widespread. So cloud architecture is a natural fit. Again, identical data platform, slightly different set of edge connectivity facilities, and then very different diverse type of either water treatment management, wind or solar farm management, similar architecture, different type of industrial applications. Third scenario that I would like to show you again is actually in hospitals. We have engaged in very energetic discussion with many of the leading hospitals in Greater China. Physicians, they're probably among the smartest type of guys, right? And they are particularly keen to adopting new technology to improve their competitiveness or their professional recognition. So we recently have many dialogues that doctors would like to actually collect the data from their ICU, collect their data from their dialysis stop, and then apply AI to improve their management efficiency, all right? Again, exactly the same data platform can be applied, but then different set of edge connectivity for the hospital scenario. On top is either managing iWard, outpatient, or ICU. So we pleasantly found out that the data platform actually is of generic utility, right? When we start to think in the data-driven format. So this is actually one layer deeper into what we have put together to construct this data platform. So they are basically a microservice-based design with edge connectivity corresponding to what is happening on site. Then with a lot of house managing service they put into it, and the data infra into it. And then again, on top is the visualization and asset performance, asset management equipment, right? Either medical equipment or manufacturing equipment. And then AI framework services by pulling in the AI, various type of AI models that are good, proven to be effective for this scenario. So some example, these are real solutions already deployed in the field based on this data platform with our partners in managing their numerical control machine in the Greater China region. Basically, the sites of their deployment, then down to line in that manufacturing facility, down to a single machine's critical information, and then down to this single machine's historical performance and the problem that this machine has encountered in the past period of time. For that more business intelligence type of presentation, we also have this continuous production scenario for a process, for process plan type of control scenario with the critical asset and the vital parameter associated with that asset in action. Again, this is in a chemical plant, a lithium battery production site, a 3D modeling of the site of all the equipments in the premises and the operating parameters currently on that. Again, this is energy management systems management dashboard where it offers a 3D flyby of all the critical energy consumption or energy production points, right? And whether the energy usage of that complex is within the expected range, and if there is any above normal situation, alarm gets triggered, notification gets sent. And then the management policy of that is beyond so-called rule-based, threshold-based, upper or lower limit-based. Actually, based on the data, based on the learning of historical patterns, we can do better with trained models, with AIs. So come to the how we leverage AI in dealing with all these different type of diversified application scenarios. In WisePath, we offer so-called AI framework services. You could see that it's actually pairing edge intelligence and cloud intelligence. So AI is actually, it fits and collaborates between the edge and the cloud. All right, so AI itself actually has life cycle, right? There are some type of AI that are trained for general purpose problem, like face recognition. But for industrial scenario, whether a particular equipment is operating within the normal range or is operating at its optimal phase, or is it going to need some sort of service in order to maintain its best performance, it requires a lot of domain knowledge. It requires a lot of in-depth experience. And actually, AI is actually very effective toward that if we can get strong, powerful label data. So at the edge, it gets, probably in the beginning, good enough model, get deployed, and through the course of using it, the line technician may find that at some point the model is not as accurate as they like, and they would, add additional label to it. So the model will get trained, will get refined, will get reinforced, will get more accurate as more we use it. So it's pairing cloud and edge. And then, again, it's data-driven, so it all begins with data. Then with the so-called the AI training infra, it requires computation resource, right, to crank out useful models. It's not like, again, it's not like getting a general purpose pre-trained model will cut it. Very little you will find that. So start with data of specific problem. You go through the compute resource. You pairing up with some candidate of effective algorithms, including possibly using AutoML to do network architecture search. And then you get a useful AI model candidate. You deploy it to the edge. Start using it. If you like it, keep it. If you feel it needs improvement, you label it. Train again, deploy again, and there's lifecycle management. And then we can span across different industrial segments at the same time. One example actually deployed on a major process, a petroleum process plant. In order to produce consistent quality from the refinery process, temperature is one of the critical parameters. And temperature fluctuates with many, roughly 50, 60 other parameters associated with that process. The plant would like to know whether the temperature would stay within reasonable range, and they would like to get a little bit more aggressive in judging the output of the result, of whether that batch of production is within the higher grade or not. If only they can get 1% more into the higher grade, the whole project would pay for it and more. So with that architecture, it deploy data collected, labeled through the model, and then we get pretty good capability, pretty good prediction accuracy. Comes to the asset performance management. With the AI bring in, we get the additional tool to be able to reduce unplanned downtime, improve the equipment availability, reduce operation costs, and then improve the quality yield. Again, within that framework, there is the pairing of edge and the cloud. Within the cloud, there is the generic model building, the so-called digital twin, the compute resource management, the organization account role management, and the like. All right, so that is a combination of several resources, several services toward addressing industrial equipment and bringing AI to improve the performance, the productivity of that. One example is, again, an actual case that deployed in the steel production factory. When we talk about AI model, particularly in the industrial scenario, we're talking about many different machines. Sometimes it's similar machines, but many stop of them. One AI model does not really cut it. A model that is good, accurate for this machine, when you deploy the model to the next machine, even from the same manufacturer and same model, because of the accumulated usage pattern is different, the model's accuracy would need to be recalibrated. So in this case, again, from collecting data, training the model, deploying to the edge, actually running the model, testing the accuracy, labeling the data set that require additional refinement, and then deploy back to the edge again. And we are able to address roughly 300 stops with 300 different variations of AI models to specifically tune for that particular equipment. Security, the friend from Trend Micro mentioned it a lot. It's important, but it's complicated and it's everywhere. All right, so this is just for reference. We have a marketplace that we invite our partners to put their solution on top and going into a subscription mode. So if you get a little bit curious and interested with WisePass, welcome to check into it. Flexible instances, we can run on public cloud, we can run on private cloud. We also go into partnership with partner together. Live instances, we have live public cloud instances running, 2 on Azure, 1 with Ali Cloud, 1 is with Inspert, all right? Private cloud, I mentioned some customer will not go otherwise. Detailed introductory information at the knowledge portal, technical manual, detailed sample codes at the technical portal. All right, so we're here looking for partners to join effort on this cross-discipline industrial AIoT revolution. We think this is actually a new way of technology being brought into all sorts of professional practices to improve their competitiveness, their productivity. And this is a brand new opportunity within, I think, the last 50 years. We feel it's a great opportunity. It has to be partnership to be successful. Thank you for your attention.
And thank you, Dr. Alan Yang. The next speaker will be Dr. Jiao Huang, Chairman and Chief Executive Officer at CyberLink. Dr. Huang founded CyberLink in 1996 with the focus on developing world-class digital video and internet technologies. He leads a dynamic team that keeps on delivering innovative products and has propelled CyberLink to transform into an award-winning global brand. Today, he will talk about facial recognition at the edge. Please welcome Dr. Huang.
Hello, everyone. Thank you very much for spending your time to attend my session. I'm going to talk about face recognition and its application and the ecosystem. So I'm the chairman, CEO of CyberLink. I will be talking about, AI on face has been something amazed a lot of people. Me, myself, as a researcher, I've seen the recognition rate has improved so much before we have AI in our technology roadmap. If we look at the market research, many companies actually have the same results. If we look at the x-axis, market potential, so certainly it's better to be there. The y-axis is the technology readiness. So clearly, we want to be on the upper right, meaning huge market. Technology is already ready. For example, autonomous driving, driverless car, huge potential. But I think the technology still takes time, right? So if you look up there, who is up there, the upper right, is the face recognition. Another thing is that many times AI is run in the cloud. A good trend and a major trend is for face recognition or many other AIs, edge computing actually is also a big trend. So we are here looking at the AI trends in 2019 and the next year and the next. Clearly, face recognition and edge computing are 2 very exciting areas. And that is going to be my focus of today's talk. So who are providing AI solutions? We know there are many solutions from China. We know there are many solutions from the States, including AWS, Microsoft, or Google. Now, the solutions from AWS, Google, Microsoft, mostly cloud computing. They're not really focused on edge. Therefore, the opportunity for CyberLink to be in Taiwan is that we know Taiwan is the world's center of making, designing, manufacturing IoT devices. So if we talk about edge computing, Taiwan gotta be, the center of designing to manufacturing. And for them to design the device, CyberLink is very committed to provide local support with the best technology to enable the fast-growing facial recognition ecosystem. So today I'm not only talking about face recognition, I really am talking about how to make that go into edge devices and how to work with the ecosystem in Taiwan, supply the world's devices to make this feature appealing in many applications. Therefore, if you are the device maker or application users, system integrators, for any reason you don't want to use solution from China, you don't want to use cloud solution, CyberLink is here to help. Now, how good is CyberLink's face recognition engine? We have attended 2 big tests, and for one of those is NIST. NIST stands for NIST, stands for National Institution of Standards and Technology. So it really is the most important test that every vendor will submit to because it is run by US Department of Commerce. So on the NIST, we rank in the vendor ranking in the top 20, okay? With the accuracy rate, 97.9%. Last year, another big one actually is run by also a competition. It's called MegaFace Challenge. It's run by University of Washington in Seattle. They are actually the first independent research institute, really is a university, to run million faces facial recognition competition. And CyberLink ranked number 12. So if allow me to show the results, as you can see, this is the NIST ranking by vendor. The red colors are those solution suppliers from China, and so CyberLink is right there, okay? This row really is talking about, okay, the table, how to read it is, if you can only mistaken like Zhao into another person, this is error must be below 1 out of 1 million, meaning you try 1 million times, you can have 1 mistaken people. Under the condition, can you recognize Zhao as Zhao, right? So that is this percentage, the error rate. So as you can see, CyberLink is number 18, and these companies are pretty much all within 1% difference. So CyberLink already clearly with this test, this result is March, actually just came out a couple months ago. So CyberLink already have the world's best technology. Similar things talk there, so let me not repeat. So now it's proven that we have one of the world's best solution. How can we help? How can we help? So again, CyberLink is not developing face recognition only in our application. We are providing our face recognition as an SDK. So we are willing to license to all device manufacturers, system integrators, for them to make their device. What could their device be? Their device can be a signage, a kiosk, a POS, a security system. And because all these device makers, they may choose different OS. So FaceMe supported Windows, Linux, Android, iOS. The next slide actually is more important. I talk about edge devices, right? Okay. So we actually developed 2 versions of FaceMe. One is very accurate, precision rate 98.5%. But we would recommend to run on a server machine with Xeon processor, with NVIDIA discrete GPU. But this is not edge device, most popular platform, okay? This is. So we trained another FaceMe model, which is only 2% of this one. Only 2%. Let me say this again. This model size, not the model is how big is the AI brain, is 250 megabyte. That one is less than 5 megabyte. To be more precise, 4.6 megabyte. So it dropped from 250 megabyte to 5 megabytes. So it is only 2% of that size. What does that mean? It means the computation required can also be dramatically reduced. Therefore, this one, as you can see, it actually can run on Snapdragon 410, not even the 800 series. If CPU, it can run on Celeron. And the platform, it can be Windows, Linux on Intel, Linux on ARM, and then NVIDIA Jetson, Android, and iOS. So I think this slide probably is the most important slide other than the ranking of FaceMe to prove it is one of the world's best engine. It shows that we cover both server and most importantly, CyberLink is committed to work with device makers, the ecosystem, the design and manufacturing center, Taiwan on AIoT, that we are capable to support different CPU framework, different operating system, and we provide local support if there's a need. Give me 1 hour. My engineers can be in your lab. So this is what's going to make this ecosystem very exciting. Now, so given that you can make all kinds of different form factors, okay? And that is why today when we talk about IoT, many times we talk about AIoT. And CyberLink is here. We are committed to help grow the ecosystem. So basically, the value proposition CyberLink's FaceMe provide is we have the world's most precise engine. I mean, we have one of the world's most precise engine. The center, we are optimized for cross-platform. So whatever platform you choose, we have a solution for it. And then when I talk about platform, we also have a customized, smaller brain, if we call it as a brain, that will fit very well on edge devices. So you can see what we can do by this video. If a person come to our FaceMe, you take his name as Marco. The next time when Marco comes in, we not only recognize this person is Marco, we also recognize the gender is a he or is a she. We recognize their age. We recognize their emotion. Are they happy? Are they sad? Or are they angry, right? And so we exactly can do face detection, landmark recognition, and facial attribute. Now you ask me, why you want to test this? Right? So I'm going to show you the market example that why we need that later after this slide. This slide is actually as important, if not even more important. Facial recognition competition are all assuming the photo is reasonably taken. But in real world, if you have an IP camera shooting at visitors entering your office, because the person is moving, so many times, the image will be a little bit blurry. So we have a technology to do edge enhancement to remove the blur problem. Another thing, sometimes the lighting is not perfect. Like this case, many of you are in the dark. So if the lighting is not perfect, our True theater technology can also improve the lighting. CyberLink has been a video company for more than 20 years. In fact, this is what we do before we do AI. So we know all these already very well. This one, very typical. If the lighting is not perfect, CMOS sensor normally would generate noise. So you're going to see a lot of noise on the video. So we have the technology to remove the noise before we feed to the face recognition. The last one is image upsampling. Why? Because sometimes the IP cam is a little bit too far away. So your face in the IP cam become too small. So small they cannot be recognized. So we want to be able to make it larger, but not just by 2 by 2 make it larger, because whatever is blur is blur. So we have the half pixel, quarter pixel interpolation technology. So when you enlarge the photo, it is not, the blur can be dramatically improved. So this is the technology CyberLink has developed over the 20 years before we have AI. So we are very glad that we have these ready to feed before we feed. So we call this pre-processing. We pre-process the video before we feed it into the FaceMe engine. Now, let's talk about applications. It is really what makes people feel excited. This one, very typical. If there's a sign, there's a digital signage. If there's a camera, signage is about advertisement. So if the camera says, oh, now in front of this, the digital signage is a he, then let's show advertisement for he. And if this one says, oh, it's a she, and then we even know the age, and then we can show the advertisement for she. Because we can tell the emotion, so we can see if she's happy, if she's not happy, not smiling, maybe we want to change another advertisement. So it can make your digital signage advertisement very precise. This one is as important. If I'm a shop owner, I own a shop, I want one question very important. I want to know who come to my store. Who come to my store? How many are he? How many are she? What are their age group? Are they more silver hair or are they more younger generation, right? So this one I can analyze to know my customers. Most importantly, I can have the system recognize the VIP that customer has spent enough money on my store. I want when she or he comes in, I instantly offer him or her, a cup of tea or coffee. So that is VIP identification. As important is blacklist. Okay, we have several customers. They said one of my customers is a phone company. They said many people come to steal phones, and there's a chain store. So they want to prevent other stores to see if they're potential person that might steal phones. So as you can see, we can detect not only the smiling VIP, also the blacklist. And we can also identify how much time the same user spend in your store. So this is very important for smart retail, okay? Let's take a quick video. So this one shows how this technology can help smart retail. Next one, clear security, right? Access the door with your face. Lab, research lab, always very sensitive, right? We don't want other people to steal our secrets. A kiosk, that can help visitors to identify who they are, answer the right question, or that is the real case. One of our customers is a smart pharmacy in a hospital, because in the hospital, some of the drugs or medicines are experimental, which such that they are very expensive, okay? And some are controlled, so only limited, some people, restricted people, can go into their room to retrieve the drugs or medicine. So face recognition would be an excellent choice. Now, another one, this is going to be big, banking. All the banking is trying to allow you to use your face in front of ATM if you forgot to bring your wallet. So your ATM card is not with you, and you need $500 to take taxi home. Okay, can your face allow you to retrieve some money? And also, would it be possible that you use your mobile phone to do mobile banking, right? Sure, we can recognize face. Now the problem is, what if I use a photo to cheat the system? I use my wife's photo, then I can withdraw my wife's money. That is one thing I always wanted to do. So we call this anti-spoofing. Anti-spoofing, one technology is using 3D CMOS sensor. So if it's a flat photo, I can't do it. Another thing is a 2D, because many of your phones, unless you have a latest iPhone, doesn't have a 3D camera sensor. So we also want to allow that 2D anti-spoofing. We also have that technology. Allow me with the video. We have the anti-spoofing demo at our booth in Hall 2, Nangang. So when you have time, welcome to come to our booth. These are so many interesting applications we already have. This is our customer, Syscom, Lingchun. They have a robot with our eyes. Okay, so it is face me looking at the customer, provide the service to customer. This is for policemen when they pull over a driver, a car, and who cannot present the ID, so can just use the phone, take a photo, and then link with the database to identify if he has a problem or not. This one is amazing. This is about vending machine. We know young people cannot buy cigarettes. There's an age, as well as liquor. So the vending machine would have a slot for you to put in your ID, driver's license, whatever ID, and then ID has a photo. That photo then compare with this photo, and compare the age on your ID. If your age is illegal, then bingo, you get your cigarettes and all your beers. This is one pub, same thing. You go to pub, they check your ID. So these are, I'm not talking about stories, what it can be done. I'm talking about our existing customers or potential customers, what they are already doing, okay? So this one, when you go to a bar, a pub, at least they can do this detection to make sure your age is safe. If not, then they come check your ID, right? And this one is a newspaper. They have taken more than 10 million photos of all those celebrities, or anything happened, they take photos. And many times, like today something happened, they take that person's photo. They want to find that person's photo in the past. How do you do that if you don't tag those photos before, right? So face recognition is a great way to do that. So I'm showing this to you is that just to let you know this is exciting, so many possibilities. CyberLink has been working with partners, Acer, BYOC, with your camera that is ready to put on any digital signage for smart retail. We work with Syscom, as I said. The robots now can tell the people, are these people happy? Is he sad? So the robots can be very smart, can be very tender and nice. We work with Tashi and also work with microprogram about door access. It can be actually, this is actually can be very small, not as big as this wall. So it's a very small edge device, a microprogram program on access control. We work with AirTag and Himax on 3D CMOS sensor. They provide the sensor chip, right? We work with the MSI and IEI on allow the tablet, industrial tablet, to have the facial recognition technologies. So these, the FaceMe already have a lot of, we have more system integrators. I do not put here because I'm trying to, for Computex, more on the edge device cases. But system integrators, we are doing a lot of banking POC and among others, okay? So, smart cities, smart retail, office, home. That's why I said at the beginning, facial recognition has such a great opportunity in the industry, all right? Before I quit my presentation, I have one video to entertain you. Especially, I see so many female in the crowd. Now assuming if you are a she, and then assuming you have a customer in New York, want to have a video call 5 a.m., their 5 p.m. is our 5 a.m. What do? So, we have two problems. One's too early, no time to do makeup. Two, you don't want your room to be seen by foreigners, right? Especially if you are a she. Probably okay, my room is just messy, right? But, you know, so CyberLink has a solution, real time. We make makeup on you. You really have to try. Better yet, we make your background. See? You want to see the demo. You don't want to see me. You enjoy. You see the difference, right? She's changing color. This is all real time. It's not by video production. This is all real time. Product is called Perfect Cam. The background. Now background is blurred, so you don't need to worry about how messy. Even replace another background. Yeah? Look like executive, you know? Another room. Oh, you have to try. You really have to try. You know, I'm glad. Many times I present to people in IT, they are all he. I'm glad I have so many she's here, okay? You know the pain. You know the pain that 5 a.m. makeup would take 30 minutes, and you don't want to go to office, but you also don't want to do it from your room. So this is amazing, okay? So the product is called Perfect Cam, and I'm glad that I make you laugh, okay? So CyberLink has a leading facial recognition technology. We want to enable the ecosystem. It's not about only CyberLink. We want to enable the entire AIoT, which has Taiwan is a major base. We want to be part of it to enable this ecosystem. So other than a great technology, we also need to make up our engines known to the world. So if your product have our face recognition, you don't need to worry your customer challenge. Cyber who, right? Face you or face me? So we have attended since this year CES, Singapore IoT show, Las Vegas, this is about digital signage, Tokyo AI Expo, we just did Seoul, and then today we are doing Computex. Next month we are going to Korea again. We are going to do a lot of trade show. We have attracted tens of thousands. Just CES, we have more than 10,000 visitors. Korea, we have more than 10,000 visitors. How do we know we have more than 10,000 unique visitors? Look, because we can recognize visitors' face characteristics so we know are they the same person or are they different person, and when they put their face in front of our system, we take the number. So we have amazing success with tens of thousands visitors, with more than hundreds of ongoing customers using FaceMe. Okay? So this is the solution that CyberLink is providing. So I'm inviting you, if you have time, come visit our booth at Hall 2, 4th floor at Nangang. That is all I have for you today. Thank you very much. Thank you.
Thank you, Dr. Huang, for joining us and sharing your insights with us. And the last speaker of the forum will be Michael Clegg, Vice President and General Manager for Embedded and IoT at Supermicro. Michael Clegg is a leading innovator in high-performance, high-efficiency server and IoT solutions. He's also a successful technology executive who has secured market leadership in product categories covering cloud SaaS, fixed and mobile, broadband, Wi-Fi, video, and IoT. And today, he will talk about generalized cloud and edge compute architecture for AIoT. Please welcome Michael Clegg.
All righty. Good afternoon, everybody. So they always say when you give a presentation, the rule of the presentation is tell them what you're going to tell them, and then tell them what you told them. Now, by sheer coincidence, watching all these presentations that have been given today, we're going to follow that order exactly. So I'm going to finish up with tell them what they told you. So it just works out that that's how the presentations have been. And I particularly want to thank the Intel speaker because he did such a great introduction that you'll see a very close correlation between what he spoke about and what I spoke about. So it's been a while since I've been in Taiwan. I used to come here fairly frequently, so it's good to be back. I want to thank Taitra for the opportunity to speak here, and to Yvonne and the other ladies that have been so helpful in getting the presentation done. So what I'm going to do is a slightly different approach. I'm not going to talk so much about products or about trends. What I'm really going to talk about a little bit in what underlies AI and IoT. That's sort of a trend that I've observed over my time from the early days to now. So I used to be a technology consultant in the early 90s, and we were approached at the time by a fairly famous semiconductor company that said, what are we going to do with 100 million transistors? This is kind of quaint, right? Today we have billions of transistors on the chip, but back then, 100 million transistors was really distressing because the thought at the time was that computers didn't need that many transistors, and there was no point in developing the semiconductors unless there was a real market. So we were looking at what sort of applications could use that up, and one of the purposes, of course, was to move some of the hardware into software, as we'll see. More recently, Mark Andreessen, founder of Netscape, said software is eating hardware. His point here is that basically hardware is becoming pretty generic, unimportant. I don't think that's actually true, because ultimately all the software still has to run on hardware, but really the differentiation and the functionality is in software. We will see if that's true. But then NVIDIA comes along and says, forget the software stuff, AI is eating software. So what does that mean? So we'll have a look at that a little later. And then finally, I was at a 5G conference in Denver a couple of weeks ago, and while we were having lunch, mixer sort of lunch, somebody said, is programming dead? Now, at the time that he asked me that question, the context was a little wrong. But it did spur my thinking, and my answer was, to some extent, when it comes to AI, programming is dead. So we'll take a quick look at that as well. Okay, so what did we end up doing with 100 million transistors? Well, if you think of a PC in the 90s, for those of you who are old enough to do that, and particularly in Taiwan, of course, this is where you make all the PCs and the motherboards, the home of PC motherboard. You used to buy a motherboard which was full of discrete logic. And not only that, but you had to buy several peripheral cards to put inside it if you actually wanted to do anything. So really, products were very hardware focused. If you fast forward to where we are now, what have we done? We've taken all that functionality and we've put it in software. So today, if you buy a low-end PC, it doesn't even have a dedicated graphics card. It just uses the CPU to do that. The audio is managed through DSP that, again, is run by the main processor. If you're watching a YouTube video, you don't have an MPEG decoder in your product anymore. You're just doing that in software. And likewise for storage, a lot of storage, particularly with flash storage, is now really driven by software. So the picture at the bottom is a Mac motherboard. And essentially, if you dig into that, what you'll see is a processor and a bunch of memory, and not really anything out. So really, we've taken all the hardware and we've turned it into software. So you see this in the smartphone as well. So this is a simple picture. All these products have been absorbed by a smartphone. Not so good if you were one of the guys that make one of those products. We think of smartphones as being expensive, but really, if you take the cost of a smartphone and think of the sum of the cost of all the things that we replaced, that's not actually that expensive. And if you go forward, you see people saying, well, maybe if you do a little bit of searching on the internet, there are at least 50 things your smartphone is going to replace, or counting. So we will continue to see this capability as long as software continues to replace hardware. Now, there's been a further trend, is we've continued to develop transistors, we've continued to expand the CPU, but at the end of the day, there's only a finite amount of transistors you can throw at a CPU. We've done multi-threading, we've increased the pipeline, we've done prefetch, we've done cache. And so at the end of the day, we get to the point where the CPU is pretty much maxed out. So what do we do now? We've still got all these spare transistors. Well, we start putting more and more cores onto the same CPU. So with Intel, the latest Skylake processor has 56 or more cores coming. So we see a lot of scope now for expansion on the CPU side. The problem is that the performance that's required to perform most functions is a fraction of the CPU performance that is available. So how do we fix that problem? Well, fortunately, people started saying, well, let's virtualize that CPU. Let's make it look like lots of CPUs. So if we put a hypervisor on, we create containers, we can now fire up as many virtual machines as what we want with the virtual network functions. So we start to see this continue to grow, and we can expect this trend to keep growing over time as well. Now, this, of course, has been enabled because software has basically replaced hardware, and you've got this generalized compute that's at the bottom. So as long as you have a good processing function, you can continue to do this. Now, deviating slightly here, with IP networks, we've seen a similar thing in the telecom. If you think of a telecom network from the 90s, you had these big distributed central telephone networks with a hierarchy of switches, class 3, class 4, class 1 switches. And every function had its own protocol. So for voice, you had PSTN. For banking, you had X25. For corporate connectivity, you had leased lines or ATM. And when we started running all of that over IP, we could get the same level of network abstraction in the network as what we have now on the computer. So by turning everything into IP, you can start to have a generalized cloud architecture. This actually is an initiative by the telecom group called CORD, Central Office Reimagined as a Data Center. So all those unique central offices disappear, and they now just have a generalized compute cloud architecture, and all your protocols start to run as IP. So having done that, because this is a conference about IoT and the edge, so we have to talk about the edge a bit, you can create a virtual CPE. So you can have now a fairly large processing performance. A lot of applications that we've seen in the IoT space presented today, you're going to have some form of edge gateway. You're certainly going to have lots of IoT sensors and devices, but that information will come. You heard of the benefits of doing the AI processing local to the performance, if we look at what Advantech was telling us. So you want to keep your processing fairly local so you can have a high-performance device over there. And again, taking advantage of the capability, you can run multiple functions. So this is actually a device that we have. It runs an Adva stack for the virtualization. You can control these containers remotely, and then we can run a number of VNFs on top of that function. So even with running two fairly beefy ones, a firewall and an SD-WAN, we still have processing power left to run a number of other applications. So this leads you to a device like this, and my colleague will talk a little bit more about devices. But again, you have this generalized hardware. You have some virtualization running on top, and then on the same device, you can pretty much offer nearly all the functions that a telecom would want today in an edge device. So if you look at the telecom network itself, this has actually been accepted. So the way the 5G network is defined, particularly with the standalone network in Release 18, is that The network itself is actually assumes that you're going to have generalized compute. So you've got a commercial off-the-shelf system, generally x86. The interesting thing at the 5G conference was asked to people, does it have to be x86? So I think those guys have done a really good well positioning themselves. But you've got the series of generalized processors, generalized instruction set, running virtual machines on. You know, it looks repetitive, and that's because it is. Because no matter where you are in the network, the only thing that's really changing is the amount of processing power you throw in at the problem. Obviously, the further you get to the edge, the smaller the device tends to get. But once you get above the hardware layer into that container layer, everything above that is the same. There's in fact no reason why the network function, say a firewall that's running at the edge, that exact same software can't be the same software that's running in the cloud. So now you really have your software that you just decide where you're going to run based on the application. So we run all the way from the public cloud through the macro data center, the micro data center, all the way to the edge. We will run essentially the same architectural model of software and hardware. So what about AI? So if we move on a little further, I think we saw the same chart earlier today in a slightly different format. So we've gone through the stages from mainframe into 5T and IO Edge. So we've heard, particularly in the last presentation and the one before that, a lot of the advantages of bringing AI to edge computing. It's certainly going to help a lot. We'll get into that in a minute. But in terms of this contest, the interesting thing, and remember the last question, is programming dead? And the comment that AI is eating programming. With AI, you're not programming anymore, you're training. So think of the way that we went from computing to Excel. So before, if you wanted to solve a complex mathematical problem, you had to learn how to write Fortran. You actually had to be not only an expert in math, but you had to be an expert in programming as well. Well, then Excel came along, and all you did was you typed the formula in, and it solved the problem for you. To me, AI is a similar metaphor. Today, if you want to solve a problem, you have to write a lot of complex software. You have to be both a software programmer as well as somebody who understands the problem. But going forward with AI, as long as you have the data, you can essentially train. Somebody has to develop the neural engine, but what you can train your brain, just like we train humans, and it will learn what you want it to do and will solve the problem. This is going to democratize computing significantly. People will be able to solve applications that without having to be software programmers. We'll see what this does to the software programming industry, but it's certainly going to help the rest of us, I think. So for us, we see that AI is really, I think, going to kill software, and I think AI is going to eat software to some extent. So if you look at what do we need to do machine training, what type of generalized compute, and can this be done with generalized compute? So there are three really areas. You need data, obviously, to train your engine. You need to train your engine to learn what the application is you want to solve, and then you actually want to apply that engine to solving problems, inference. Now, the building blocks for doing all of this is, for data, it's all about storage. Right? So you want lots and lots of storage. You heard from the previous speaker how much data comes in. From the speaker before that, from factories, how much data these machines generate. Huge amounts of data coming in. You want to be able to take all of that, segment it, and store it. But again, as we've seen, particularly now with flash coming along, EDFSS type flash systems, Intel Ruler, Samsung NF Flash, that really, flash itself is just being controlled by software. The days of lots of complicated storage systems are gone. So we can scale this fairly easily. For compute is the next step. For training, you really want a lot of compute functionality. And for inference, you really want to be out on the edge. You want to get all these sensors and bring them together. So really on the data side, the training is we want these large machines, large amount of capacity. Today, we put in a petabyte of storage in a single 1U shelf. So huge amounts of data, and we can back that up with a large amount of processing power behind it. And again, we're using generalized storage architectures with open source software running on top of that. 10 years ago, you would have been buying very expensive, highly specialized storage appliances, and now you're just buying essentially standard compute and putting some open source on top of it. For the cloud, the problem is a little different. Training is very, very compute intensive. So yeah, you want a lot of processing power in your box. This you're probably going to do in the cloud, as you heard. The cloud allows you to basically scale up and scale out. You can just throw more processing power at the problem, and you can drive this to whatever you need to drive it. As you keep getting that new data constantly, you're constantly feeding the data into your training system, so you're constantly improving your system, so it gets smarter and smarter over time, so it continues to learn. Now we get to the edge. Now the edge is interesting because there's going to be many, many different applications. And what's interesting here from CyberLink, they can go from a very Snapdragon 400 series all the way to a very high performance processor. So we will see at the edge a range of devices that are going to be applied over there. Your problem is smaller here because you're only doing inference and you're not doing training. We heard again from Intel, for example, that at FPGAs, you can use FPGAs to accelerate this. What's interesting, of course, is an FPGA is just software-defined hardware. So you can program it once. You want to change your application, you download a different configuration into the FPGA. So even though it's hardware, it's really software-defined hardware. So it fits our model of generalized computers taking over a lot of the dedicated functions. And we heard a little bit about GPUs. So AI is a more complex problem. Machine learning is more complex. There are certainly dedicated processors being developed. But fortunately for the GPU guys, if you remember what we said earlier, the general purpose processors were eating a lot of the GPUs for a while. This wasn't so good if you were a GPU guy. But then Bitcoin and AI came along, and all of a sudden the GPU guys are very happy people, and they can't make enough chips. So GPUs have been really repurposed as AI machines, and we see this going on a huge amount of scale in terms of GPU processing. So now we have, again, general purpose functionality being used to provide highly optimized functions. So I'm going to stop here for a minute and have my colleague come on. Morilan Molivan's the Director of Embedded Services, and he's going to talk a little bit about some of the hardware that Supermicro has to make all of this real. You got it, Jika.
Thank you.
Thanks, Mori.
So hello, everyone. My name is Mori. In the past 3 years, this is my second time come back to Taiwan to share about the journey I have in Bay Area, the Silicon Valley. It's our honor to share with you about how we design the products after this, the trend descriptions. And I think the AIoT is getting very popular. So our job is to make it real and make it simple. So let's take a look. We select a few factors to share with you. Lots of applications will be touched in this segment, including the Cloud RAN for telco space, UCPE for the network industry, and also lots of topics for smart retails. Those things are all connected behind. And how to make this edge computing possible, there are lots of technology and possibilities to put it all together. And I choose the 12 factors to share with you the findings in this journey, how to design the edge computing products. And this will help industry to grow faster, and also together with the partners and also vendors all together. For example, you are going to have a more computing power, not just a small gateway anymore. You are going to carry lots of computing performance, so your CPU need to be powerful enough. And thanks to the Intel and AMDs, you got a lot of powerful CPU. So we designed the systems to keep it simple and compact. Not just about that, you need accelerators to make sure your workload will be integrated in an efficient way to offload lots of applications the presenter mentioned, the face recognitions, and also the body study, and also the data minings. Those kind of things require the powers closer to the edge area. And then they are no longer ship all the data back to the cloud. Because of this, the accelerator with CPU together, it's already solved 2 problems. You still have lots of things to go. You need to make it small and compact. And also, you need to handle sometimes the edge application need to be outdoored. And for sure, lots of virtualization and orchestration topic being mentioned by many presenters. I believe most of you, once you control all these factors together, you'll realize to make servers small, it's not easy. And that's why we are here, to share what we are already innovate for you. There are many customers, they share their opinion expectations to us. So we put it into 6 circles to share with you. For sure, security is the major topic right now. Everybody wants to make sure those edge devices are well protected. AI and also analytics are the 2 factors that bring lots of values back to the business. But to make this possible, you need accelerators to offload the loadings, to make CPU do their job for the virtualization environment and orchestration. And by the way, it's because of the age. So you need to make sure your device management need to be very efficient to manage thousands and thousands of locations. Because of this, you can see, we just give it a short examples. If you have a lot of the virtual environment need to be managed, it doesn't have to be the big server in the cloud. So we'll give you a choice to using the cloud computing technology, make it small, become an edge device. And In this spectrum here, you can see lots of hint. It's from the CPU technology perspective. The low power was just a starting point. You might have a fanless for the industrial IoT, and then you put the graphic card become AIoT. So you can imagine it's still all behind the Internet of Things. But to make things become possible, you need to study a lot about the technology limitations. When you have so many hot components all put together, how to make sure they can run in their very reliable status. So you require the very detailed study about the behavior from those components, CPU, accelerators, and also the rest of the peripherals. Once you combine them all together, you are going to define the size and also the flexibility to embrace those accelerators. So that's why you can see a bunch of the blue box here. It's all representing the different customer expectations behind. I've just picked one example to you, the smart retail space. People talk about face recognitions. People talk about the security topics. Have you thought about? If you have so many computing power you want to handle, then edge computing played a very important role. And people are using software-defined, no longer just networking or storage. They call software-defined storage in the store space, which become the software-defined stores. In those areas, they just need to using the small thin client, drive lots of virtualizations. And then because of this, then you need to still give them the computing power, just like the data center performance they have in the past. And to make this possible, we realized we cannot just continue to talk about the product we built here. Lots of the customer language here, they are expecting you can handling their virtualization topic and video, and also the data analytics part. To make this possible, there are several factors you need to worry and then manage. For instance, you need to make your system compact enough because they have a space concern. And you also need to make sure your performance is good enough when they have a lot of workload happen at the same time. Think about you have 100 customers processing their transaction at the same time. And also you need to make sure your connectivity for wireless communications and also flexibility for your modules. Those things all combined together make edge computing, it's a reachable target. And then to make this possible, we give them a computing platform. They start to drive the value on top of that. And to make this possible, this two-way communication is a must, instead of just keep pushing the technology. And we choose the Xeon as a scalable processor in the Xeon D. There's a reason behind. It's powerful enough and low power and able to drive those innovations together. We show you some products we are contribute to the world. And it's very simple things. To you, it's a technology can keep it small form factor. We are able to put NVIDIA graphic cards like the Tesla T4 into the system like this. 1 card, 2 cards, 3 cards. To make this possible, why they want to put so many accelerators at the edge side? Because it will touching lots of privacy topics. For sure, it's great to know my face, my age. What about if you don't want to be studied? Have you thought about that? And this become a key. They still want to study what I'm moving when I'm touching the products. So they take out my face, but they still study my move, real time, with all the data collected. So you need a bunch of the accelerator to do the job, instead of just keep studying the pictures you have. And it requires lots of powers, because you are not just pushing all the data back to the cloud and wait for them and coming back to the edge side. You want to have a real-time response. Like the example they share. They recognize you, they give you the promotion message. They recognize you, give you the immediate VIP service. But to make this possible, you need to make sure you have enough infrastructure to support this for the edge expectations. And that's why we want to let you know GPU card, FPGA cards, those things are easily to be deployed to the Supermicro edge platforms. We also have some products without accelerators, small gateway device. But those devices also possible with the Intel OpenVINO, those kind of a virtual cores. You are able to drive the AI machine on top of that for purpose-built loadings, such as you are able to just checking one single object, is this or not. So those things, you don't need to use the very, very high-end FPGA or GPU card. You basically just make sure your software are able to use everything you have. With the fanless design, you are able to enter lots of environments. Not just about that, we also have something, other vendors, they are doing this, the similar SoC technology. And we put it in a small box, there's a reason behind. Remember, the edge need to be small and compact. It's not just one player can contribute the roles, but to Supermicro, we believe the edge computing have a whole new opportunity for all of you. And then later on, I'll pass the control back to Michael Clegg. He's going to share with you more of our AIoT applications. Thank you.
Thank you, Mark. So we'll just wrap up with a couple of applications, but we'll go fairly quickly because I think you actually saw nearly all of these today, a little earlier on in some more detail. So the first one is the smart factory. A lot of talk about from Advantech, particularly around the smart factory. Again, these environments generate huge amounts of data. You go from your training and your data set up in the cloud where you can consolidate the data, or you can have these very large servers on-premise if you so choose, all the way to tens or hundreds of these edge devices scattered around the factory or built into one of these machines. As we can see, there's projected to be huge economic growth just from smart factories alone. The second one that came up earlier as well was medical applications. We're now starting to see cases where AI is getting better at detecting cancer than humans are. And obviously, because an AI machine learns all the time, a human brain, even though it sees thousands or hundreds of samples, is ultimately going to sort of asymptote. But the more important thing, a human brain will probably only look at hundreds or thousands of samples in a lifetime. You can take the entire country's AI video images, feed it into a central cloud, and let the AI machine learn on that. So it's just going to do better because it's going to be exposed to many more images and will never get tired or have a bad morning and get the wrong image. So from this point of view, it works well. We can have, again, you see the exact same hardware, because remember, this is generalized compute at the bottom, but in this case, the edge device might actually be built into an X-ray machine or a CAT scanner or an MRI machine, and we actually have applications like that with Supermicro. The third one is smart retail. Again, you heard a lot of people talk about retail applications, so I won't go into that. Very data-rich environment, very application-rich environment for what you can do. One other little one is, you can't have a presentation that's talking about drones nowadays, so I decided I need to have a drone presentation as well. So what we're going to do with our drones is we're basically going to count cars, and this is an experiment we actually did with developed together with the Taiwan University. And effectively, you fly in a drone over a parking lot, and you're basically counting the cars in real time. This is actually pretty hard. I started my career doing missile guidance image processing systems, and without AI, I can tell you doing this programmatically would be extremely difficult and take a long time. But over here, essentially, it can detect moving cars, can detect static cars, can detect empty parking spaces, and figure out what the application is. So that's a nice demonstration. How can you use this in the real world? One is obviously farming. The farming industry, if you can automatically fly over a field, find out where you must put more fertilizer, where maybe you need insecticide, what is the right time to pick that fruit to maximize your revenue, that is going to be significant. Doing this with livestock is very difficult as well. In birds, you can literally have millions of birds congregate in the same place. Plus, unlike plants, these guys are moving around all the time, and you're trying to count them, and you figure out how many birds do you actually have. So yeah, you need to sort of recognize the poultry and try to recognize the animal as well. And of course, by doing infrared, you can do this in the night as well. So again, unlike humans, and we'll see this in all the AI applications, where we kind of work 9 to 5 or 10 to 6 or whatever country you're in, but basically you work a finite amount of time. Machines don't get tired. They can work day, they can work night, so we're going to get a productivity multiplication out of that. So that's all I have today. Thank you very much, and it's been good for a session.
Thank you for joining us, Mr. Michael Clegg. You may now return to your seat.
Thank you.
And with that, ladies and gentlemen, we conclude the 2019 COMPUTEX Forum. 今年的2019 COMPUTEX 论坛到此正式圆满落幕了。再次感谢所有在场的贵宾这一次的莅临。请大家扫描证件背面的 QR code 来填写线上问卷，凭完成